Hi everyone, and welcome to the first lesson of the Generative AI for Beginners course. This course is based on an open source curriculum with the same name available on GitHub that you can find at the link on the screen. I'm Carlotta Castelluccio. I'm a cloud advocate at Microsoft focused on artificial intelligence technologies. And in this video, I'm going to introduce you to generative AI and large language models. Large language models represent the pinnacle of AI technology, pushing the boundaries of what was once thought impossible. They've conquered numerous challenges that older language models struggled with, achieving human-level performance in various tasks. They have several capabilities and applications, but for the sake of this course, we'll explore how large language models are revolutionizing education through a fictional startup that we'll be referring to as our startup. Our startup works in the education domain with the ambitious mission of improving accessibility in learning on a global scale, ensuring equitable access to education and providing personalized learning experiences to every learner according to their needs. In this course, we'll delve into how our startup harnesses the power of generative AI to unlock new possibilities in education. We'll also examine how they address the inevitable challenges tied to the social impact of this technology and its technological limitations. But let's start by defining some basic concepts we'll be using throughout the course. Despite the relatively recent hype surrounding generative AI, we can say that in the last couple of years, we have really heard of generative AI everywhere and every time. But this technology has been decades in the making, with its origins tracing back to the 1950s, 1960s. The earliest AI prototypes consisted of typewritten chatbots relying on knowledge bases maintained by experts. These chatbots generated responses based on keywords found in user input. But it soon became clear that this approach had scalability limitations. A significant turning point arrived in the 1990s when a statistical approach was applied to text analysis. And this gave birth to machine learning algorithms, which could learn patterns from data without explicit programming. And these algorithms allowed machines to simulate human language understanding, paving the way for the AI we know today. In more recent times, advancements in hardware technology allowed for the development of advanced machine learning algorithms, particularly neural networks. These innovations significantly improved natural language processing, enabling machines to understand the context of words in sentences. This breakthrough technology powered the birth of virtual assistants in the early 21st century. These virtual assistants excelled at interpreting human language, identifying needs, and taking actions to fulfill them, such as answering queries with predefined scripts or connecting to third-party services. And so we arrived at generative AI, a subset of deep learning. After decades of AI research, a new model architecture known as the transformer emerged. And transformers could handle longer text sequences as input and were based on the attention mechanism, enabling them to focus on the most relevant information, regardless of its order in the input text. Today, most generative AI models, often referred to as large language models, are built upon the transformer architecture. And that's what the T in GPT actually means. These models trained on vast amounts of data from sources like books, articles, and websites possess a unique adaptability. They can tackle a wide range of tasks and generate grammatically correct text with a hint of creativity. But let's dive deeper into the mechanism of large language models and shed light on the inner workings of models like the OpenAI GPTs. One of the key concepts to grasp is tokenization. Large language models receive text as input and produce text as output, if we want to really simplify the mechanism. However, these models work much more efficiently with numbers rather than with raw text sequences. And that's where the tokenizer comes into play. Text prompts are chunked into tokens, helping the model in predicting the next token for completion. Models also have a maximum length of token window, and model pricing is also typically computed by the number of tokens used in output and inputs. So tokenization is really an important concept in large language models and generative AI domain. Now, a token is essentially a chunk of text which can vary in length and typically consist of a sequence of characters. And the tokenizer primary job is to really break down the input text into an array of those tokens, which are then further mapped to token indices. These token indices are essentially integer encoding of the original text chunks, making it easier for the model to process and understand. Now, let's move to predicting the output tokens. Given an input sequence of n tokens with the maximum n varying from one model to another according to the maximum content window length for one model, the model is designed to predict a single token as its output. But here's where it gets interesting. The predicted token is then incorporated into the input of the next iteration, creating an expanding window pattern. And this pattern allows the model to provide more coherent and contextually relevant responses, often extending to one or multiple sentences. Now, let's delve into the selection process. The model chooses the output token based on its probability of occurring after the current text sequence. This probability distribution is calculated using the model's training data. However, here's the twist. The model doesn't always choose the token with the highest probability from the distribution. To simulate the process of creative thinking, a degree of randomness is introduced into the selection process. This means that the model doesn't produce the exact same output for the same input every time. That's the element that allows generative AI to generate text that feels, creative and engaging. Now, we said that the main capability of a large language model is generating a text from scratch, starting from a textual input written in natural language. But what kind of textual input and output? First of all, let me say that the input of a large language model is known as prompt, while the output is known as completion, term that refers to the model mechanism of generating the next token to complete the current input. Let's do some examples of prompts and completion by using the OpenAI ChatGPT playground, always in our educational scenario. Now, a prompt may include an instruction specifying the type of output we expect from the model. In the example we are seeing, we are asking to write an assignment for high school students, including 4 open-ended questions about Louis XIV and his court. And you can see that the output is exactly what I'm asking for. So the model was able to generate an assignment with the questions. Now, another kind of prompt might be a question asked in the form of a conversation with an agent. In this example, we are asking about Louis XIV in a question. So we asked, who is Louis XIV and why he is an important historical character? And we've got an answer. Another type of prompt might be a chunk of text to complete, so an incipit of a text to complete. And you can see now that we used an incipit of a text to complete as prompt, and we've got a whole paragraph to complete the current input. So this is basically an implicit ask for writing assistance. Now, the examples I just did are quite simple and don't want to be, an exhaustive demonstration of large language models' capabilities. They just want to show you the potential of using generative AI in particular, but not limited in a context such as the educational context we have used today as example. That's all for now. In the following lesson, we are going to explore different types of generative AI models, and we're going to cover also how to test, to iterate, and to improve the performance, and compare also different models to find the most suitable one for a specific use case. Thank you.
Hey folks, welcome back to Generative AI for Beginners here at Microsoft Learn. I am Pablo Lopez, Cloud Advocate in .NET in Artificial Intelligence. I'm here with Carlotta. Say hi, Carlotta.
Hi everyone. I'm Carlotta Castelluccio. I'm a Cloud Advocate focused on artificial intelligence.
That's incredible. So today let's talk about a little bit on the basics. You started on the introduction. Now let's go deeper. Let's see how can we explore and compare different LLMs. Of course, now that we have on Azure AI are LLMs, but if you want to take a look at that, we can talk a lot later. But we're going to talk a little bit about the comparisons on language models. So going from here, you're going to see a little bit of foundation models, language models, and later, Carlotta, you show a little bit on Azure AI. So what are you going to learn today? You maybe heard of foundation models. So let's understand foundation models versus LLMs and language models. How to classify a language model because they have a lot of classifications for them. And then Carlotta will show a little bit of Azure AI. Let's go with foundation models versus LLMs. But to understand this, let's start with foundation models themselves. Why? Because you may have seen a little bit heard about foundation models, LLMs, etc. You may have been confused on how those work. Let's think about it a little bit. The foundation models, they do the following. So usually it's the basis of you're deploying something new. So what does you mean about it, Pablo? Okay, let's think about like this. Imagine that I have a foundation model that I want to do multiple tasks. So here I have a teaching one. So you can put like a multimodal data source to train it. So it can have teaching materials, videos, interaction, and the subject matters. And then we have like our tasks. So we can have multiple assist students, educators, facilitate learning, teaching, and there's a subject matter. So you can see that we have a lot of input here. We have a bunch of things we are training with, and we can have a lot of tests and goals. But you see that it does a lot of things, right? But it may not do them perfectly. We may need to, guide them in how to do X or Y. So assist educators, how to assist them, right? Because we don't have like instructions to, understand how is helping it. Then it's foundation. Why? Because it's the basis of our constructing new solutions. So that's why you're calling it foundation models. And let's bring this graph as well. So let's think about this. And foundation models were brought by Stanford researchers. So that's why you're using like that. So the foundation models here are very simple. They have some prerequisites. They need to be pre-trained, generalized, adaptable, large, and self-supervised. So you may see right here that foundation models can cover a lot of things. And you may note as well, if you know a little bit about LLMs, that they fulfill all those five. So yes, LLMs are foundation models because they fulfill all those five. However, not all foundation models are LLMs because they don't use language sometimes. As I said, they use a multimodal way to learn. So they have a multimodal way to as well to answer or to interpret. They don't use tokenizer sometimes. So that's the difference. So yes, foundation models are very important because our LLMs are foundation models, but not all foundation models are LLMs. That's incredible. But now that we understood those, we're going to start talking a little bit of our language models themselves, right? So then it brings a classic, right? Open source versus proprietary. So let's think about open source a little. So when you have open source, nowadays we had like a big expansion, right? A lot of companies are doing open source language models, which are incredible. But let's think about it a little bit. So what are those means, right? So open source, usually they are open sourcing some of the parts that they use to, or train the LLM. So imagine that you have like the code that I use to train. Some provides the weights. If you don't know, the weights are basically the fine tuning of the language model, so it can like go inside and try to investigate. Or even some provide like the full model that you can just download and go and start having fun with, and you can tweak and do everything. So these are incredible. But here's the thing, a lot of them are provided by research groups or NGOs. So those usually what they have, they don't can have a lot of resources to be supported and to be updated with new features, or new updates on security, on especially if you think about prompt injection, etc. So you may see here that yes, open source is incredible, but they can have some faults here and there, or maybe their licenses aren't permissive enough with what we want to do. So open source opens a lot of small issues here and there that you need to think about if you want to solve. Proprietary, usually they are much easier. They are already provided. A lot of those, of course, they are provided by APIs if you go to cloud services. But what is good about proprietary is that you're going to get a lot of things done correctly. So you're going to have like updates constantly in the models. Of course, it limits you the opportunity to fine tune the model, but usually it means that you're going to have a lot of things that you can already use. It's a ready-made solution that you can go and grab and go. Okay, so you learn a little bit of the open source models and about the proprietary. If you ask open source, you have a bunch of them, right? We have Falcon, we have Llama, we have Llama as well. So we have a bunch here. And our proprietary can ask about, ChatGPT. So why I'm saying this? Because you notice that I didn't talk about embeddings, right? So what are the embedding one? So let's pick an OpenAI ADA. So let's talk about their categorizations. You're noticing that they have like very strict categorizations here. So let's go to a language model that converts everything to embedding. So we have a string, we have a prompt. You need some way to communicate. Imagine that, I have a format that I can communicate with different models, right? So getting it to convert to embeddings are great, because then I can easily imagine that I can use it for systems like RAG, that I can store all the embeddings and I can search and I got my information back. So embeddings are very important for systems today on generative AI. And it's not only that, they are used to communicate multiple types of language systems and language models. So it's just very simple. Pick a string, convert to embedding that everyone can understand. Then we have language models to image generation. That everyone knows, DALL-E, everyone already played, and we have as well on Web Copilot. So I have a prompt here. So you have like in quotes, and then you're gonna put in your generative AI neural network, and then boom, you're gonna have an image. So here you have a painting of a flying dog, and here you have this incredible image. Then the classics. Who didn't already use text generation, right? Everyone here already had some fun with it. So you go to your classic Copilot web as well, ChatGPT. You can go as well. If you even go to Hugging Face, right? You can access on Hugging Face a lot of the other models that have Falcon or Llama. We have Mistral. And those are incredible. So basically, you put a prompt, and then you have prompt engineer that you're going to see later in this course. And then the generative AI starts to write it, and then it generates a text. And it can be text, it can be code. We have, of course, some that are optimized for code, but you can see here that is how it works. So we have, usually, those are the three more defined ones. Well, of course, if you want to break it down, you can do like specialize, you can do a lot of, extra things here and there. Remember, you can always interact with those language models and do what you need for your business, your hobby, or anything you want to. Great. Let's talk about service versus model. Remember what I talked before, that you can easily access some of those incredible models in the cloud? Exactly. Why I said it? Because those are in the service. What it means? Those are already stored in the cloud. You cannot change yourself without going more inside and try to do some fine tuning. But basically those are stored and they are easy. Usually API calls, you just send it, send your prompt, and then you can get an answer. You need to deal with scalability. The scalability the cloud already uses a few. The security is defined on how is your security on the cloud as well. So everything is tight and niche. And not only that, you can actually integrate with all your other services. So that's the good part about having the service, right? You don't. It's easier to manipulate and do sometimes if you want to change a little bit. But of course, we're on fine tuning a bunch of those services. But that's important for you to know. But after this, you can have like easy way to interact with this. The model is a little bit harder because you need to download the model, you need to set up. Imagine that you have a server, right? And you need to take care of the server, take care about scalability. Imagine that you have multiple clients coming in. So the model is for you to interact directly. It makes easy interacting directly. It goes much more easy to try to understand how this is working and the pipeline. But imagine that you need to interact with your cloud service and need to track something. It makes much harder without the ecosystem. But you have more full control, but you need to deal with infrastructure costs, etc. So now I'm very interested. Carlota, can you tell me how Azure AI Studio, how it works? I actually don't know.
Of course. Thanks, Pablo. Yeah, I'm happy to walk you through, how to use foundation models in Azure and specifically in Azure AI Studio. And the first question I want to cover here is why Azure, right? So in the ever-evolving landscape of foundation models, selecting the right candidate for your specific scenario is just the beginning of the journey. So once you have identified your top choices, it's time to put them to test on your use case. So Azure AI Studio is your one-stop platform for developing, testing, and managing the entire lifecycle of your AI applications. In fact, this platform integrates Microsoft data technologies for optimized storage and search in databases, a wide range of proprietary and open source large language models that Pablo just presented. For example, from the OpenAI family, but also from partners like Meta, Hugging Face, or Mistral. Tools that enable ensuring responsible and secure development of AI applications, but also prompt engineering and evaluation facilities, as well as monitoring assets for generative AI applications. Now, recalling our educational startup scenario, let's imagine that after extensive research, our startup has explored the current large language models landscape and have pinpointed some strong contenders for their unique scenario. Now, the real fun begins because testing these models involves an iterative process using experiments and precise measures to ensure they meet the mark. And where they can, where they can test these models. They can do that using the model catalog in Azure AI Studio. Azure AI Studio provides a seamless experience with a user-friendly interface. So here's what you can do in the model catalog. You can easily find a foundation model of your interest by using different filters, such as you can search for the model provider. That can be Azure OpenAI, can be Meta, can be Hugging Face, and so on and so forth. You can search for inference or fine-tuning task. For example, you can search for Q&A or summarization task or object detection for computer vision kind of scenarios. And also you can filter by license, for example. And you can even look for a specific model, of course, by searching its name in the search box. Now, once once you select a model, before you proceed with the deployment of the model itself, it's always a good idea to get to know your model a bit. So the model card in the model catalog provides a comprehensive view complete with detailed description of use cases and training data of the model you selected. And for some models, you can also find some code samples, providing us with a sense of how inputs and outputs look like for real-time inference. Also, sometimes a bit of fine-tuning is necessary, and Azure AI Studio empowers you to improve your model's performance with custom training data for a selected subset of models in the model catalog, like Llama 2 70B that you see here in this slide. Once your model is, primed and ready, it's time to deploy it. whether it's the original pre-trained model or your final tuned version, Azure AI Studio has you covered. In terms of deployments, for a few models like Llama 2 here, or the ones of the Meta collection in general, you have a couple of options. You can go with the standard deployment approach, which is real-time endpoint. So you deploy your model in your Azure subscription and you manage the infrastructure used for inference. Or you can use the recent pay-as-you-go type of deployment that has been introduced. And this means that you can consume, in this case, Llama 2 model as a REST API without caring about the underlying infrastructure, with an experience similar to using Azure OpenAI Service APIs. So just consuming it as through a REST API. And this is what we call model as a service. Now, another interesting feature of Azure AI Studio is the model benchmark. Here, you can basically compare different models in the catalog using filters to determine the specific subset against some predefined performance metrics such as accuracy, fluency, coherence, and so on and so forth. And there are several test data sets you can choose to use for the comparison. When it comes to deploying large language models into production, businesses have a world of options, each with its own set of complexities, of course, cost, but also quality levels. Let's dive into these approaches and see which one suits different requirements. The first approach is leveraging prompt engineering with context. Now, pre-trained large language models excel in handling general language tasks, and you can simply feed them a short prompt like a question or an incomplete sentence, and they work like a charm, right? And we call this zero-shot learning. But here's the catch. The more context you provide, the better the large language model understands your request. And when you include detailed examples and request, this approach is called one-shot learning if you're using a single example, or few-shot learning if you're using multiple examples. In the case of a conversation, you can even use the prompt to describe the personality of the assistant, for example, the style and the tone of the responses, or pass the conversation history into the prompt. This approach is cost-effective and a great starting point. Then approach 2 is using retrieval augmented generation, which is a pattern, I would say, a specific technique, prompt engineering technique. In fact, large language models have their limitations, and because they only know what they were trained on and can't access post-training information or private company data, for example. And to bridge this gap, we use this pattern, retrieval augmented generation, that adds external data in the form of documents chunks to your prompt, effectively expanding its knowledge. So we are passing data through the prompt, but before doing that, we are going to use some search pipeline to look for the data to add to our context. In Azure AI Platform, this is powered by vector database tools like Azure AI Search. RAG is a valuable approach when you lack the data, the time, or the resources to fine-tune your large language model, but you want to boost its performance and minimize the risk of incorrect information or harmful content. The third approach I would like to cover here is fine-tuning. Fine-tuning is a process that customizes an LLM for a specific task. So it generates a new model with updated weights and biases, making it ideal if you have strict latency requirements, so you cannot really have a huge context in the prompt, or you possess high quality data and ground truth labels and you can maintain them over time. So fine-tuning with respect to RAG requires additional computational resources to adjust the weights of the model. Now, I want to say that these techniques I have presented here, so prompt engineering, retrieval augmented generation, and fine-tuning, are not mutually exclusive. They are complementary. So there are cases in which you are going to use, for example, prompt engineering and fine-tuning. Other cases in which you are going to use the three of them. The last approach I want to cover is training your own large language model. Now, training an LLM from scratch is a huge undertaking, demanding vast amounts of data, of high quality data, skilled professionals, and serious computational power. You'd consider this option only if you have a very domain specific use case and also an abundance of domain centric data. In the world of large language deployment, there's no one size fits all solution. So the right approach depends on your unique requirements, resources, and goals. Also, the techniques we explored, as I said, are not always mutually exclusive. So there are cases in which you need to evaluate if you need to combine a few of them. Also, any choice we take in terms of training and deployment, we should be conscious and transparent about the technology limitations and use responsible practices and tools. In the next episode, you'll discover what this means. But for now, I would like to wrap up. And Pablo, hey, I want to bring you back just to say goodbye, everyone.
Folks, it was a pleasure to talk more about generative AI. Carlota is incredible as well to learn more, and I'm really excited to, talk more with you folks. I'm gonna come back soon as well for more lessons on generative AI for beginners. Thank you so much, and learn more with Microsoft Learn.
Awesome. Thanks, everyone.
Hi, I'm Corey Stegerrod-Pace, part of the AI Cloud Advocacy team here at Microsoft, and I have the pleasure of delivering lesson number 3, using generative AI responsibly, to you today. And, using generative AI responsibly is important. Whether you have 1 user or 1,000 users or 1 million users, it should be really at the cornerstone of everything you build with generative AI applications. So let's dive deep into this concept and actually look how we can apply it when we're building applications for users. So as an introduction of this lesson, we're going to look at why we should really prioritize responsible AI. I mean, we put this lesson up early in this course, but we want to make sure that everything we do is wrapped around responsible AI. Then we're going to look at the core principles of responsible AI and how they relate to generative AI in particular. And then lastly, we're going to put these principles into practice. It's great to have some principles, but how do they actually apply to building generative AI applications is important to talk about. Our goals for this lesson are, we're going to see the importance of responsible AI when building generative AI applications. We're going to learn how to apply those core principles of responsible AI. And then lastly, we're going to leave with some tools and strategies that you can use today to put these principles into practice. So why should you prioritize responsible AI? Here at Microsoft and in this course, we want to focus on taking a human-centric approach to application development. And what that really boils down to is the user's best interest equals the best results for your application. And generative AI, we realize can create tons of value for your users, but that value can be lost in an instant in terms of when responsible AI is also not maintained. So we need to make sure that impact requires monitoring and that intent is not enough. We don't think people go into all the time saying they're going to build an irresponsible generative AI application, but we do think that if you're monitoring it and making sure, even if you don't expect these things to come about, is that you have the right necessary systems in place to deliver a responsible experience. So let's look at the potential harms that we might have with working with generative AI applications. The first one is ungrounded outputs or errors. These are most commonly known things like hallucinations or fabrications. And they can be sometimes funny in terms of nonsensical responses, or they could be harmful, like factual errors that might be used in other systems, or even contradictions in responses, whether it's stating a claim in one sentence and then contradicting in the other, or just even presenting completely irrelevant information to the user. The next one, it's not so funny, and that's harmful content. Large language models can produce instructions, and whether it's encouraging things like self-harm, hateful or demeaning content, or providing instructions maybe for either finding illegal content or even acts of illegal content. So we need to make sure we keep an eye on that as well. And then lastly is the lack of fairness. I tell my kids all the time, life isn't fair, but generative AI systems should definitely be. And fairness really equals being free from bias and discrimination. So this is making sure that the output is not producing anything that has exclusionary worldviews or has any bias towards any particular groups. This is particularly important, especially when we're talking about generating images or text. And this aligns well with Microsoft's own responsible AI practices, whether that's being fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. So how to actually use generative AI responsibly now that we understand the potential harms that could come about? Well, the first thing is to measure these potential harms. And we've encouraged taking like a similar idea to software testing, but also making sure that you're doing things like prompt testing. And what this means is you're actually aiming for a diversity of prompts that that might be potentially used from your user. And these aren't the ideal prompts. These aren't things that always like you expect the happy path for your users, but making sure that anything that might come about when you're deploying your applications to users or them using your application, that you incorporate that in your prompt testing. I would like to say you should start manual. So you can, sending a prompt to the large language model and receiving and evaluating that response. But you can also scale this to automation as well by batching these prompts and then also seeing the results there. But starting manual gives you a high touch and very clear understanding of how the large language model is responding to your use case. And there's 4 layers of mitigation that we're going to discover today as well. One is on the model level, building a safety system, using correct meta prompts, and then lastly, on the user experience side. So let's look how this actually plays out in practice. First is the model side. I like to say really easily, right model, right use case. Well, large language models can do many things, but some of them are either more specialized than others. And using the most powerful model is not always better. Where you can maybe use things like a specialized model that maybe is more attained to your use case, or even knowing the sort of parameters, things like model temperature and how that affects responses, and even the option of fine tuning or using a fine-tuned model that may be even more geared to your use case or what your users will be using your application for, are all great ways to mitigate on the model side. Also in safety system, things like content filtering, so making sure that the responses from the model goes through a filter and does not present any harmful content. Also using things like responsible AI and building out scoring and metrics on responses. And then lastly, monitoring the model and its responses are all great ways to build a good pillar of safety systems. Next is meta prompt. And this is really how we sort of define the behavior or rules for the model in terms of how it engages with users. We can ground the model on context or even using trusted data by using techniques like retrieval augmented generation, which is actually covered in this course as well. And then lastly, and most importantly, is on the user experience side. Building transparency to users in terms of that they are engaging a generative AI application or a model is very important, as well as even putting things like constraints with inputs from the user side so that you limit and mitigate the harms that they could bring about with their prompts. And then even doing some input or output validation on the responses are also great ways to deliver a great user experience and a responsible one. And now let's say putting this responsible AI into practice. We've looked at the concepts, we looked at the mitigating harms, but how do we actually get started? Well, within Microsoft, we have things like the Azure AI Content Safety. These are API endpoints and tools that allow for this information information in your responses to be presented in a way that gets scanned before they being delivered to your users. Whether that's analyzing the text, building things like prompt shields to scan text before for any user input attacks, as well as groundedness detection, making sure the model is grounded in the source materials that have been provided by users. We also have the responsible AI dashboard, which allows us to keep score essentially on how the model is being responded and being interacted with our users, and gives you a good understanding and overlook of how the model performs over time, which is very important in terms of not only when we deliver this generative AI application to production the first time, but the 6th time, the 10th time, or the 100th time. And then lastly, we can do great things with monitoring via prompt flow. Prompt flow is an open source tool, but we can also use it to find out and understand the type of responses that are being delivered to users. And we have metrics around this, whether it's coherence, the type of responses, if it's coherent, if it's fluent, the groundedness, as I mentioned earlier, is it relevant to the actual prompt, and how similar is it to other prompts that we have seen before. These are all great things to give you an oversight and put those responsible AI principles into practice. And that covers this responsible AI lesson. You can check out more information in the full course at aka.ms/genai/beginners.
Hi, welcome to Lesson 4 of Generative AI for Beginners. My name is Nithya Narasimhan. I'm a Senior Cloud Advocate on the AI Advocacy team, and I'm excited to talk to you about prompt engineering fundamentals. So today, we're going to first start off with a quick recap. If you've been following the series, you know most of the terms. We'll just look at them really briefly. Then we'll talk about the 3 providers that you can use if you want to get started trying these out on your own. But most of this is going to focus on prompt engineering. You're going to learn what it is, you're going to learn why it matters, you're going to learn how to do prompt engineering, and then we leave you with a sense of intuition for how you can build your own mindset for prompt engineering in practice. So let's get started. A quick recap. If you've been following this course, these terms are probably familiar to you. What is a prompt? So we're talking generative AI, large language models. A prompt is just the natural language input, the text input that the user provides. And you can almost think of it as the way it programs the model to do what it wants, or the user programs the model to do what they want. So the response is then what the model does to kind of support the user request by generating content. Fabrication, you might have also heard of it by the term hallucination, is when sometimes the model generates a response that may not be rooted in fact, and we'll talk about that. A base LLM, or large language model, is really this foundational model that's trained on massive amounts of data. Think of it as a general purpose model that knows everything. But sometimes you want specialized models, things that know how to do a task very well. And that's what you look at for instruction-tuned LLMs, things that are good at summarization or translation or code generation. So what is prompt engineering? Prompt engineering is really this process where you iterate on the prompt, the text input that you give to the model, study the response, and keep going till the response looks like what you want it to be. To understand that, you need to understand how it works. So let's take a look at how the model works. Chat completion is this very basic thing where you go to the model, that's you in the pink prompt, you give it your text input, and it gives you content. Done, right? But wait, what's prompt engineering? It turns out that there are a lot of little things you can tweak that will help the model tune the response that it provides you. So for instance, you could have prompt templates that the user's input is put into that provide additional context. You can look at the conversation history. You can do things like retrieval augmented generation and ground it in data. There are system contexts. There are model parameters. So with prompt engineering, we're really looking at how do we kind of like adjust all these variables so that you get the best response you can for the prompt. But before we get started and dive into the details, let's talk about your choices. Now, if you've been following the course, there's a Getting Started folder that'll tell you how to set yourself up with one of these providers. You can go with OpenAI or Hugging Face, or you can set up on Azure AI and use both models in there with Azure OpenAI or Azure AI Studio. Today, for the most part, we're going to use OpenAI because that's something that's really accessible to you. But you can check out the repo for notebooks to use the others. Once you picked your model, again, you have 2 choices for trying out exercises on your own. You can go with the no-code option where you don't need to know any code at all. You just go to the sandbox that they provide. Or you can use the notebooks that we've given you that are set up with your credentials, and then you can do interactively programming exercises to learn prompt engineering. Today, we're going to pick the no-code option. So now let's dive in. Are you ready? The first thing we need to understand is why prompt engineering? What's the motivation? Number one motivation is models are stochastic. What that means is if you ask the model, if you go to it and give it a text input, there's no guarantee it's going to give you the same response every time. There's no guarantee that the response is going to be correct. There's no guarantee that the response is what you thought it would be. Let's take a look at what that means. So what we're going to do is we're going to try out some of these exercises. First, I have some of these providers set up. So here is Hugging Face. We're actually going to use Hugging Chat, which is their open source chat implementation, which has a model built in. And right now we're using Microsoft 5.3. I also have it set up with OpenAI, their playground. And on the other hand, I have Azure OpenAI as well. So we're going to start by giving all of them the exact same prompt. Let's see what happens. So I'm going to go in here and ask, let's start with Hugging Face and say, hey, tell me about the element gallium. And you'll see that it's giving you a proper response. Tells you it's a chemical element. But look at what it's giving you. It's like a multi-paragraph response, right? So you go to this provider, this model, you get this response. What happens if I tried an OpenAI? Here I'm using GPT-3.5 Turbo, and you'll see that it's given me a response, and it's shorter, and it seems different, and it keeps going. Wow, okay, but they were not identical, correct? Let's try this with Azure OpenAI, and by now you know where we're going. So I'm going to say, tell me about the element gallium. And remember that Azure OpenAI is using OpenAI under the covers. You'd assume that it would look similar to the other one, but it's not exactly. And this is what we mean by stochastic, that the same request going to different providers, different models is going to generate different responses. But wait, you might tell yourself, okay, providers are different, but if I stick to the one provider and just do everything with them, that's not an issue, right? Okay, let's try it out and see. So I'm going to say, tell me about the element gallium. And first, let's look at the response with GPT-3.5 Turbo. And you can see that it's giving me a response which has 3 to 4 paragraphs. Now I'm going to cancel this response, switch this to use GPT-4 Turbo. Same provider, right? Should look similar. Not exactly, right? You can see that the text is different. It's doing something different. You can see that it's actually giving you stuff in Markdown. I didn't say what I should do, but you can see the response is different. Same provider. But wait, it gets better. Let's try something different. We're going to go back to GPT-3.5 Turbo, but now I'm going to basically say, tell me about the element gallium, and let's just keep it short so you can see the difference in one sentence, right? Now, the reason I want to do this is I want to show you something really interesting. This sounds nice. I've already engineered my prompt to give it a shorter response. But if I submit this again, you'd think it should give me the same response, same model, same request. I haven't changed anything, but look, it's different. This is stochastic. This means that if I were to try to use the responses from this model for my actual application, I have no guarantee I'm going to get the same thing multiple times. But want to see something fun? It gets worse. See this thing called temperature? If I change this and say, hey, get more creative, the bigger I make it, now, when I tell it the same thing, it gives me something completely different. It tells me everyday electronics to medical imaging. I don't even know if it's true, but it tells me something different. So you can see that by changing the parameters, changing the model, changing the text, we can actually get different responses. And that is challenge number 1. All right, let's look at what else we can do. We've tried all these. Oh yes, system persona, I forgot that one. That's a fun one. So here, by default, the system persona says you're a helpful assistant. So let's say, tell me about gallium. And we already seen this, but now we'll make it fun. We'll tell the system, your persona is you are a cheerful or you're a creative assistant that only speaks in limerick. All right, let's see what happens. It gives you limericks. So now you see how you can change the quality of the response by trying to tune all these parameters. That's your first kind of like step into understanding the power of prompt engineering. But it also exposed to you the challenge of stochastic responses. There's no determinism. You don't know what's happening. But there's a second challenge. Remember, we talked about fabrication. Models can fabricate responses. And because of how they work, you may not even know that what they're saying is not grounded in truth. Because remember, a model doesn't really understand, doesn't know the meaning of what you're asking it. It's just predicting tokens. It's predicting the next word based on its global knowledge. So it'll look realistic, but may not be true. Let's try it out and see. So what we're going to do is we're going to look at two different models in OpenAI. We're going to look at GPT-3.5 Turbo. Its cutoff date was September 2021. So it only knows about things prior to that date. GPT-4 Turbo has a September 2023 cutoff date, but it's also one of the more newer models. So it kind of has already been given a little extra sauce to make sure, it doesn't fabricate as much. So we're going to go to these models and ask them who won the 2025 Oscar for Best Picture. And yes, 2025 has not happened yet. So let's try it out and see what happens. So we're going to go in here, and we're going to first start by saying, and let's start with GPT-3.5 Turbo. And I'm just going to copy this in there. Oh, and let's reset this because I want this to go back to being just the default assistant. So now I'm saying who won this, and it's GPT-3.5 Turbo, and it doesn't tell you that it doesn't know it's not fabricated. It just says, I can't tell you real-time information, which itself is weird because 2025 is not real time. But hey, that's okay. Let's see what happens when I go to GPT-4 Turbo, which is a newer model. I give it the same thing. But what this is doing is telling you, hey, I don't have information because you're giving me a date that doesn't exist. So this is actually a little bit smarter. But now let's go back and try something interesting. Remember that GPT-3.5 Turbo told me that, hey, I can't tell you because it's real-time information. Let's try changing it just slightly, right? We're asking the same question, but we're going to change it slightly. And instead of saying who won it, say, tell me the premise for the movie that won the Oscar. We're saying it won. Tell me what it was. Let's see what happens. Do you see what's happening? It made up a movie. It even told me what it did. This is fabrication. There's no way this movie exists because 2025 hasn't happened yet, but it did it. This is fabrication. Now, let's see what happens if we ask GPT-4.5 Turbo, which is the newer model, right? Or GPT-4 Turbo. This one is smarter. It's going to come and say, I can't deal with 2025. It hasn't happened yet, right? So this is a fair one. And just kind of like, make sure we are not doing the wrong thing. We can try to have it tell us about the 2015 big Oscar, which did happen. And sure enough, it gives you the right response. Both of them will do. So here I can go ahead and do this with GPT-3.5 Turbo, and this will get it right as well. So what did we learn? We've learned that the prompt engineering model has an issue with stochastic responses and with fabrication. And prompt engineering is what we need to do to improve the quality of that response. So now let's dive into how we can do that. So over here, we're going to look at the first and more, the kind of like the high level principle, which is start by giving your model clear instructions. We're going to go through a bunch of demos here, back to back. First, we'll start with the basic prompt, just let it complete it. Then we'll iterate on it with conversation. Then we'll instruct it. We'll kind of make it clearer by giving it specific instructions it should do. Refine it for the specificities of the task, the format, the length. Then we'll try doing something called primary content to see if we can stop the fabrication or ground it in real data. Look at cues, and finally look at something interesting called few-shot prompting or providing examples. Let's get started. So here, I'm going to go back to the the OpenAI model. We'll stick with GPT-3.5 Turbo. Everything reset back to like the default assistant message. We'll start with our basic prompt. So I'm just going to go in, and I want to just show you what prompt completion looks like. So what I'm going to say is I'm literally, and this is how you know that it really doesn't understand context. I'm just giving it, oh, say, can you see? Let's see what it does. It comes back to you with by the dawn's early light. It's literally just completing it. So this is a basic prompt that does completion, right? No context. I didn't give it a task. It just predicted the next things. And lo and behold, anything starts with that is likely to be the national anthem. Now let's try a complex prompt. So what I'm going to do is I'm going to change this now and say, okay, let's go back to our gallium. And I'm going to say, hey, what is gallium? And it comes back to me and tells me, hey, this is this element in the periodic table. But now I can get into a conversation, right? So I can actually say, and this is where it gets interesting, I can say what follows it. I didn't give the name, I just said what follows it. And it automatically connects the context to what I asked before. So this is one of the first techniques in prompt engineering, that we can refine the response by getting into a conversation where we're interactively trying to get it to improve on the response from before. But wait, now we want to talk about using instructions. We were just looking at basic prompts and how you can do complex multi-turn conversations. Now let's get serious. So let's assume that I'm a middle school teacher and I have to do a lesson plan for my kids on the Civil War. So I go over here and I say, hey, I need to kind of have something I can put on a slide that helps them understand the Civil War. So I go over there and I say, hey, write me a short essay on the Civil War. And you can see it's writing me this really long essay. And this is great. I don't know how much of it is true, but that's a lot. I don't know. I mean, like, I couldn't read this in class. So I'm like, I actually need to get more specific. So the first thing for prompt engineering when you want a better response is you try to make it more specific. So what we're going to go in here, and we're going to basically, let me get rid of this one. And I'm also going to change the maximum length to something smaller so we're not being overwhelmed. And what we're going to do is we say, write a short essay on the Civil War, but I'm going to give you more instructions. Provide key dates for the events. Tell me the significance. Identify key figures and their contributions. Because this is what I want to teach my students, right? And if you try this, now you can see that it is actually beginning to answer according to the things that I asked, right? So it's telling me the events, it's telling me the issues, and by the way, if I continue this on, key figures, and that's because I'd set this minimum length to 192, so the first response came back with that many characters, and then I had to hit it again for it to continue on, right? But you can see it's answered my questions. But this is still a little too much, right? I want to kind of make it a little bit better because this is not, my students are not going to read all this stuff. So what can I do? Let's try to improve it by now defining the length and format. So I'm going to take the same thing and we're going to try to improve the prompt. And this is literally what prompt engineering is. You keep iterating. Now I'm saying, provide a list of dates, etc. But now give it to me in Markdown. And 2 paragraphs, that's all I want. 2 paragraphs and give it to me in Markdown. Notice how it's formatting it for me in Markdown. It's giving me 2 sections. It's giving me a bulleted list with the dates. I can now copy this into a web page or into a slide, and it's clear, concise, and better. Much better, right? But now let's talk about, remember we said fabrication? How can I potentially try to reduce the amount of fabrication this could have? So to try this out, first I'm going to take a question from the Civil War. And I'm going to say, okay, let's ask this question. Who fired on Fort Sumter? And it gives me this information. And I don't know if this is right or wrong, but more importantly, let's say I asked my students to read a particular paragraph and come back to me with a relevant response. I can check if this is what's in there. Now we're going to talk about this thing called primary content, where now you can actually provide an instruction where you give it the grounding context. So I can actually put down, and this paragraph is actually from Wikipedia. So I can put down the content, the primary content that is relevant to this particular question. And then I ask the question. I'm like, okay, who fired on Fort Sumter? And if you look into this, the answer is actually in this, right? So Confederate troops fired on Fort Sumter. And if I hit an enter, it tells me exactly what's in there. And the interesting thing is, if I hit enter again and again, you'll notice that the response remains consistent. It's no longer as stochastic as it used to be, because now I've literally given it the context, the primary content on which that question should be asked. Much better, right? What else can we do? Well, let's say, for example, this particular teacher not only wants to get the answer, but wants to get the answer to be phrased in a certain way. This is where you can use something called cues. So what happens with cues is if you ask a question or you tell it to give it an instruction, you can kind of, it's like a cold start, you can nudge it in the direction you want it to go. So let's try this out. I'm going to start with a simple instruction. Tell me about 5 popular fruits. And it comes back to me with a whole bunch of information, right? And I'm like, that's not what I wanted. I wanted it to tell me something, and I want it to be in alphabetical order. So what I'm going to do is I'm going to do this and say, okay, tell me about this. And then I'm going to hit this, and I'm going to queue it up. I'm going to queue up the response. I'm going to say, tell me about 5 popular fruits, and then say the 5 popular fruits in reverse alphabetical order are, and if I did this right, it gives me the same fruits, and they're in reverse alphabetical order. I kind of seeded it. I nudged it in the direction I wanted it to go. But wait, it gets better. I'm looking at this going, this is not what I want. I want those kids to remember it. So I want to kind of give it some examples of how I want this to, how I want the response to be done, right? And so we can do this. And this is called, first we're going to talk about zero-shot prompting and few-shot prompting. So here, I'm basically going to start with zero-shot prompting, where I'm saying, I haven't told you anything. I'm just giving you an example. And I'm going to see what it does. And you'll see that it continues on and tries to describe this fruit. So it didn't learn anything. It's just like continuing on. And I get a decent response. But it's not what I wanted. What if I went in and instead said, hey, what I really want is for you to talk about fruit, but I want you to make it into this kind of like this. Hey, these are maybe elementary school kids. So I'm like, A is for apple, a fruit, that's sweet. Now let's see what happens when I hit an enter here. Do you see? It not only was able to look at the pattern and see, hey, there are 2 at a time, but it figured out that they were alphabetical. I didn't tell it. It figured it out that they're alphabetical. And this is the most interesting. It figured out that they rhymed. Sweet and treat, red and spread, indeed and freed. You see that? So this is where you can effectively tell it examples of what you want to see, and it tries to learn from them, not learn from them, sees the pattern, if you will, and tries to use that pattern to give you a better response. So all of these are techniques you can use for prompt engineering. And with that, let's kind of get back to our slides and wrap up what we were talking about. We talked about clear instructions. You want to try this out, go try out the assignment that's in the lesson. And you can do that with a code-first approach by putting in your credentials. Once you've got that, what can you do next? As you notice, the best way for prompt engineering, you have to iterate, iterate, iterate. So you can do things like change the persona, change the parameters, add examples, understand limitations. And when you're done, when you've got it to the point where it looks good, create a template. So that next time you don't need to go through the exercise again, you know exactly the prompt that you need to ask, put it in there, share it with all the other teachers so they can use it too. And this is exactly what we do when we think about prompt template library. So I encourage you to go look at this site as an example of how you would build a prompt template library for your application. This is Prompts for EDU. But you might be telling yourself, well, not education. I want to know how to write prompts for something else, for retail, for gaming. I don't know. This is where I encourage you to go look at the provider sites. OpenAI has a prompt examples collection. So you can go look at what a good prompt looks like, how to set system context parameters, etc. Hugging Chat will let you pick any model and then literally give it an example that you can see how it works on it. And Azure AI has a prompt catalog. So you've got a good place to start from. And with that, we come to the end of lesson 4. So to recap, if you are interested in what we were doing today, we learned core concepts. We understood the challenges of generative AI today in terms of prompt usage. We figured out what are the different techniques for prompt engineering. And we looked at ways in which you can go and build your intuition by using templates and examples from other providers. We can't wait to see what generative AI applications you build. See you in the next lesson.
Hey folks, my name is Chris Noring. I work as a senior cloud advocate at Microsoft. In today's lesson, lesson 5, we'll talk about how to create advanced prompts. You can definitely check out this link here at the bottom, aka MS Gen AI Beginners, where you will be able to find all the different lessons that will skill you up from beginner to expert. Now, as we move in, let's check out this lesson, right? You can see that this is part of a GitHub repo. There's a ton of different lessons here, so we definitely recommend that you check out all of these lessons to make sure that you skill up properly. The goals of this lesson is to learn how to apply prompt engineering techniques that improve the outcome of your prompts. And hopefully by now you saw the previous video where we introduced the concepts of prompts and prompt engineering. And this takes it to a different level where we explain that there is actually a method and an engineering principle behind getting a better result, because that's really what we're trying to achieve. So for example, if we look at a very basic prompt, you see that it says how to generate 10 questions on geography. That's all well and fine, but there are some hidden clues in here that makes this a good prompt, because we are providing context by saying geography. We're also limiting the output by saying no more than 10 questions, not 20 questions, not 30 questions, not 50 questions, but 10. And this is an important principle when it comes to be better at prompting, which is what you're about to do. One other thing, when it comes to a topic, when you go into a topic, just imagine that it could be a very big topic. So the more you can drill down into specifics, the better. So for example, if you're interested in Paris and London, you should say that instead of UK or France or what have you. So always think about providing just the right level of context to ensure that that output is what you need. And the format is also something that we can work on. So far, you saw how we said 10 questions, but you can also decide how you want that output to come to you. Like, for example, with a title, a description, or maybe some other keywords. So these are just some good grounding, some basic tips on how to be a better prompter. But there are also some various techniques that we're here to learn today. And this is something that you can take with and run. And it doesn't really matter whether you're using Azure OpenAI or ChatGPT or some other AI assistants. These are techniques and technologies, approaches that you can use anywhere. So what you've seen so far is a principle here called zero-shot prompting. This is your most basic form of prompting, where you construct a prompt, you're sending that to your AI assistant, and you hope for the best. Now, one other principle that you could be using also is something called chain of thought. And what we want to say about this principle is that, imagine this. Imagine that you are a student and you are a teacher, right? So the student would guide you through a problem by saying, Chris, to actually solve this problem, you need to take a few steps. First, you need to do A, then B, and then C. And then you try to mimic what the teacher does. And little by little, you're able to take on more and advanced problems and kind of conquer those. That's the idea of chain of thought. But now imagine instead of a student and a teacher, it's you who are the teacher and the student is really the LLM or your AI assistant. So you are guiding it step by step on how to actually present the solution to a problem. We'll quickly show an example of that one. There's also something called generated knowledge, and the idea is to improve the response of a prompt, and you can provide generated facts or add additional knowledge that then the AI assistant can utilize to present you with a better response than if it didn't have those facts. And then there is a principle called least to most. It's very similar to chain of thought, but this is about breaking down the problem into a series of steps. And we see how this could be really useful in, for example, data science, where it's often known which steps that's going to happen in what order. For example, fetching data, cleaning data, and doing some other projections maybe, and then you end up training maybe a machine learning model. And there's also a couple of techniques here that I thought to mention at the very end of things, which is self-refine and meiotic prompting. Now, the idea with self-refine is that you are actually critiquing the LLM, your AI assistant, and said, are you sure about these facts? And what you're saying to it is not only that you're questioning the very output, but you're also saying, how can you improve this response? Just to give it a few different iterations of saying, oh, you're really sure about this response. How about you try and go for another round? Meiotic prompting is interesting because what you want, just like with self-refine, is that you want to make sure that the outcome is correct. So what you do is that you break down the answer, which might consist of, let's say, 5 or 6 different parts. And for each and every part, you are trying to ascertain whether that response from the AI assistant is actually correct by getting it to countermand itself by giving you a different response. So definitely look at self-refine and meiotic prompting if you're interested in validating your response. And also something, so why are we doing this in the first place? Why do we need techniques to actually ensure that the output of our AI assistant is correct? Well, the truth is it doesn't know everything, right? And just like us humans, we make up responses when we don't have it, especially if we're kids, right? But it's the same thing with an AI. If it doesn't have the correct answer, it's trying to give you its best guess what it should be. And this is a way for you to tell the LLM, are you really sure about this response? You didn't make it up. This is also known as hallucinating when it comes to LLMs. But yeah, now that I've described these various principles, let's look at chain of thought, because I find that this one is super interesting. So imagine now that you have this simple problem where you say, Alice has 5 apples. She throws away 3 apples. She gives 2 apples to Bob, and Bob's give 1 back. How many apples does Alice have? Now it answers us with 5, and this is problematic, right? Because 5 is incorrect. If you actually do the math for this, you see that you should calculate it as 5 minus 3 minus 2 plus 1, which is 1. And it's actually answering us with 5. So how can we actually come up with a better response? Well, and this is where the whole chain of thought comes in. And this is really the teacher and the student idea. So the idea, what you're doing is to show the LLM, you show your AI assistant, here's a similar problem, here's how I break it down, and then hopefully you end up with a more accurate response. So what you can do is give it a similar example where you say that Lisa has 7 apples, she throws away 1 apple, she gives 4 apples to Bart, and Bart gives 1 back. And then you show the calculation being 7 minus 1 is 6, 6 minus 4 is 2, 2 plus 1 equals 3. Now, this is super interesting, right? Because now you've shown a similar examples, but you've also showed the calculation. And then you add the original question being, Alice has 5 apples, she throws away 3 apples, gives 2 apples to Bob, Bob gives 1 back, and so on and so forth. And lo and behold, now the LLM will actually answer you with a correct response, which is 1. So just to rehash what we did here, we provided it with a similar example. We provided it with a calculation for how to calculate this very similar answer. And then we re-added our original question. And all of this is called chain of thought because we teach it how to do things in a chain. So we're showing the entire calculation, the entire chain of thought from start to finish, and our LLM, our AI assistant, is now able to answer us better. Now, looking at generated knowledge, this principle is also super interesting because this allows you to provide information to your question as you need it. So what we're looking at here is a template. We see that this is a template because it's using these curly brackets with company and company name and products list. This is information that doesn't exist yet. And for this question to be able to be posed towards the AI system, we need to fetch this information from somewhere. And once we fetch this information, once we include it into our prompt, then we will be able to get a better response from the LLM. And this is oftentimes used in a principle called RAG, or retrieval augmented generation. The idea is that you fetch existing data that you own as part of your company, you insert that as part of your template, then you ask the question to the AI assistant, and then you arrive at hopefully a better response than if you had just tried to ask the LLM the question right away. So imagine now if we go, just to show an example of this, if we just ask it, please suggest an insurance like this. So we go to our playground that we can have, and you definitely have the same kind of playground. So what we can do here inside of this playground is we can paste this, and this is not fetching any business data, it's only fetching the actual question. So at this point, we're saying, please suggest an insurance, giving the following budget and requirements. My budget is $1,000, and it should be about car and home, or even better, let's remove this part. And then what we want to do is to scroll down all the way to the bottom. Let's see if we can do that. So now we can come to a point where we hit generate button, but now we're going to get a response where we just hope that the LLM is actually trained on insurance products, and we get a very generic response. So we're not really happy about this response because it says, well, for $1,000, there's multiple insurances, but this is not really what you want, right? Because most likely you own an insurance company and you want that insurance products to actually be something that you tell the user about. So if the user come to your site, they ask about the best insurance, you actually need to fill stuff out. So instead of just asking this question, provide that extra context. And now we pretend that this extra context has been fetched from somewhere before the user's request is actually coming through. And this is what we call a RAG. So imagine now that we fetch this information thanks to doing some web API call with Acme Insurance. We're showing it all the different insurances. And now we still ask the same question. We have a budget of $1,000. And at this point, we want to go back and we want to hit generate. And this time we're hoping for a better answer because we provided it with more context. So now we can see, because we added this generated data, we asked our question of $1,000. Now it's saying to us, here's a much better response. You should be using the cheap insurance of $500 that's within your budget, or you can use the other one for $600 and so on. All of this is based on this improved context. But of course, the devil's in the detail here, right? How do we actually fetch this data? This is where RAG solutions come in, and you need to build a system around it. But the good news here is that we have many samples on Azure, how to do this for Python, for JavaScript, for Java, .NET, and so on. So don't worry, we got your back even here. Yes, we went through this example, and you can see how much better the prompt was when you were able to, in runtime, provide that extra context while asking this question. And just to show you also about least to most, that this is a principle of how you're able to present it with a breakdown of a problem. So as I said before, let's, for example, use this within data science, and we can actually start with a prompt in which we say, well, how would I do data science in 5 steps? Or how would I make this chocolate cake in 5 steps? By having this initial prompt, we are actually able to use the LLM, and we get some kind of recipe for how to solve our problem. So here we're saying collect data, clean data, analyze data, plot data, and present data. That's excellent, right? Because once we have that breakdown, we can actually use each of these steps and go back here and say, how would I do collect data in data science? So now we're utilizing the fact that we've already asked that initial prompt, how we do data science in 5 steps. Now we're using the information of knowing what one of these steps are called, and we can just make that information important with a quote, and now we hit generate, and now it's able to give us a better answer about how to do data science because we mentioned a specific step. And if we want to be even better with this response, show me Python code. And this is just utilizing all of those great principles when it comes to prompting in general, that if we add more context on how to do something, we are more likely to get the response we need. And by me adding show me Python code and collect data in combination, you see that I now get some kind of answer that makes sense. So now it says how to read data from a CSV file, and it's showing me how to do header information on the data. It's showing me how to select various features from that data set and so on. So you can see context matters, and the more specific you are. And I think you all saw this when I didn't say show me Python code, it just gave me some text. It didn't really show me what I needed, which was the Python code. And yeah, as I mentioned before, self-refine, this is a very important process when it comes to critiquing your results, to say, are you sure about this outcome? And here you can see an example of this technology where we're saying, we first start off with a prompt where we say, create the Python web API with routes, products, and customer. That's a great start, right? But what you want to do as part of the self-refine is to say, suggest 3 improvements of the above code. So here we're saying, we're not really happy with your first attempt, but we want to iterate on the results. And now we can say 3 improvements or 5 improvements or just any improvements, and we arrive at a better response. So we can keep self-critiquing n number of times until we're happy with the end results. And meiotic prompting is also an interesting one, is that we can ask the LLM to answer a question. And for each part of the answer, we can ask it to explain the answer just to make sure that what we're getting back seems consistent. If we notice any kind of signs of inconsistency, that's probably something that we can discard, because then the LLM is just making stuff up. And we can see here, for example, of how can we create a crisis plan to mitigate a pandemic in 5 steps? Great, we get 5 steps back. And for each step, can you explain more in detail how I can deal with each of these? But if we come to a point now where it starts to explain one of these steps and it doesn't seem like what it's explaining back makes a lot of sense, as I said before, is probably something that we can discard. Hopefully, you'll be able to feel like you're skilled up in your prompting, you've leveled up, you now feel like you have different options. Chain of thought was a fantastic pattern to use if you wanted to lead it in its reasoning. If you feel like it's doing wrong for some reason, it really helps to provide that example, to break it down in steps and even showing it the calculation and critiquing the result. You saw how you could improve that source code step by step by just asking for do that improvement or do this improvement and so on. So with these patterns, you can see how we can improve the quality of the output, because that's really what we want at the end of the day. We want something that's more correct or more to our liking. So huge thank you everyone for watching this video. Okay. Hey folks, welcome to another video in this series about generative AI. My name is Chris Noring. I'm a senior cloud advocate at Microsoft. And in this very exciting lesson, you'll learn how to build your own text generation app. Isn't that super cool? As usual, you can go to this bottom link here at the slide, aka MS Gen AI Beginners. That will show you the entire series of everything you want to know. But this lesson is very hands-on, so without further ado, let's go into Visual Studio Code, your code editor, where you can see how we can craft our own code and build our own AI augmented app. So let's start off here where we used to be, right? We have an open text window. There are a couple of things I want you to know about building apps like this. One of them is how to import Azure OpenAI. We're going to need this to instantiate a client. But before that, we need libraries called OpenAI and .env. OpenAI, this is the library that helps you make it easy to make those calls towards your Azure OpenAI or OpenAI resource and get that response back from your AI assistant. The other bit here is going to help us during development time, and it's called .env. .env has the role of loading secrets and other environment variables from an environment file. The idea is that you have some kind of key value setup where you say, these are my keys and these are the values that go with it. In general, and this is a very strong recommendation, don't put anything that's secret within your code. Separate secrets from your code, typically by having them as environment variables or elsewhere, somewhere that's not the code, because what happens if you check this in, someone will be able to use and authenticate and use your resources. You don't want that to happen. So what we're looking at here is how .env helps us by taking the values within the .env file, load those in as environment variables, which makes it simple then for us to refer to them as we instantiate our client. So here we're building our client by calling Azure OpenAI. There are 3 things it needs to work. One of them is an endpoint. This is something that you can find within Azure Portal with your deployed cloud resource. Next piece of information that it needs is the API key. And this is your unique secret that says that you are you. And then we need to specify the right API version. This one tends to change over time, so definitely check back to our official Microsoft Docs to make sure that you're using the right version. Using the right version will ensure that you have access to the right features on Azure OpenAI. Now, deployment is also one of these things that's important, because you can deploy more than one model on the same cloud resource. So imagine that you want to, for example, deploy DaVinci or maybe ChatGPT 3.5 Turbo. You need different models for different things, especially if you try to embed code, that's a model of its own. You try to do chat conversation, that's another model, and so on and so forth. So you need to read up a little bit on what kind of deployment that you need. But you can think of deployment as what type of model am I using? Now on line 18 here, this is the interesting part, right? This is what you feed into your AI application. This is the prompt. This is the instruction that you want some kind of answer to. So in this very simple case, we're saying complete the following, and we're saying once upon a time there was a something something. This is a fantastic example of how you can build your own story. So if you got kids at home, or maybe a niece and a nephew, and you want to tell them a great story, why not use that AI assistant to be able to do so? And here we establish something called messages. And this is how we can establish some kind of prior conversation. So this could either be you starting out your conversation, or this can be a whole list of messages between you as a user or the system. So let me just show you quickly what I mean in case you wanted to establish a really long conversation that's been happening for a while. At this point, you would just add this and say that to the system, for example, that you are a curator at the museum. So if you change like this will mean that your AI assistant suddenly changes behavior, that it needs to consider this piece of information before it responds. So this could be super interesting if you want to build an app, for example, that works for museums. Or you can either say it's a curator at the museum, or you could even say that it's Abe Lincoln, and it would actually tell you a story like it was Abe Lincoln. So lots of different options when it comes to messages, how to customize either by saying that there's a previous history of messages that happens, and you continue your AI application with a conversation that you already had, or you use this as an opportunity to kind of tweak that AI assistant of yours to make sure that you get very interesting responses. For now, we'll keep this very simple. All we want to see at this point is a simple prompt and a simple message to make sure that that is actioned upon. Now, to make the actual completion, to get that response back from your AI application, we are calling completions crate. And you see here how we set the variables model and messages. And after that, we are trying to print the response coming back as message.content. So without further ado, let's actually try to call this piece of code and make sure that we match the name here, AOAI. Let's see, nope, not that one for now. So this is the very simplest form of this. So give this a couple of seconds because it needs to establish that connection with your resource in the cloud, and then it sends the prompt, and then you hopefully get that response. So assume that this will take a couple of seconds the first time you run this. But hopefully you'll see how it executes all these lines of code up until line 24, where it should output things. Now, looking at this, if you remember once more what we wrote to it, said complete the following, once upon a time there was a something. So at this point it would already tell us here's a fairy tale. And you can see here, if you scroll up, that we got a very long response back where it says, so if you read this all the way through, you see that you have a fantastic fairy tale where it says, once upon a time there was a beautiful princess named Aurora who lived in a magnificent castle at the edge of a vast kingdom. Now, if you want to tweak this fairy tale a little bit, once upon a time there was a girl who lived on a spaceship, you will get a very different story. But this is the beautiful part, right? You can take this prompt and tweak it to whatever you want it to do. So now when we ask the very same question again, run this app, we have tweaked the prompt with a different instruction. So hopefully this time around, we get more of a science fiction type setting. Now, if you scroll back, we have our unique story. So if you are a parent, if you are an uncle or aunt, you will be able to be that favorite relative who always tells net new stories. So at this point, we have a girl here called Nova that lives on a spaceship since she was born. And Nova is fascinated by stars and the possibility of discovering new planets. I'm already hooked. I want to hear more about this story, and I hope you want to. Now, this is nice, right? I mean, we have a fairy tale story. That's already something that's very useful. But if you want to have an everyday kind of application, you might want to look at an app like this instead. So in an interactive app, you probably have a way to collect information, and how we collect information in Python is by using an input construct. And at this point, we want to tell the user what we're after. So we're saying, I want you to name the number of recipes, for example, 5, could be 1, 2, 5, and so on. We also want to ask the user for what ingredients do you have in your fridge or your cupboard. So at this point, we're saying, we think you have something like chicken or potatoes or carrots, whatever have you in your fridge. And then, of course, we want to make sure that we are inclusive. So we add some kind of filter that if you are allergic to peanut, we don't want to show you some kind of peanut recipe because that would be bad for your health. And then after we've inputted all of these ingredients, now we construct a prompt that has these templates here with the curly brackets. So number of recipes would be interpolated here. The ingredients in your cupboard would end up here. And the filter would make sure that we don't have, for example, any recipes containing peanuts. And then ultimately we'll do just like the fairy tale application and set messages. And then we end up printing the response. So there's quite a few different bits here. So what we want to do at this point is to clear things up a little bit and see if we can actually run this app as is. So A, O, I, like this and this. So now that we run this, we expect to be prompted. So number of recipes, 2. List of ingredients is, well, if you know Chris, you know that he always have chocolate at home. And he probably has, I don't know, caviar. Maybe not the best ingredients for creating something, but hey, it is what it is. And filter, I'm not allergic to peanut, but let's just humor me and say that I am. So at this point, we just wanted to produce a recipe based on this user-driven input. So now it's not only producing recipes that I can use, but also shopping lists. But let me show you the 2 different recipes that we did get. And the first recipe is chocolate caviar tart. Now, I have to admit to myself, I've never tried chocolate and caviar together, so I'm not sure it's a winner. But this one tells us about all-purpose flour, butter, sugar, okay, heavy cream, chocolate chip, and caviar. I'm a bit, I'm not sure, but hey, let's give it a try. The other recipe here is chocolate caviar truffles. I don't know if that works, maybe it does. Heavy cream, caviar, cocoa powder. But at this point, you might be thinking, that's way more ingredients that I might have in my cupboard or fridge. I mean, and for that reason, there's a shopping list. I'm not sure this app works as it should, but I think you get the idea here. So that if you want this app to actually respect the ingredients you have at home, you can always tweak the prompt and say, so here below here, you see that produce a shopping list and please don't. So I thought I was being very courteous here when I say please don't. You can actually use very strong language here and say, and all ingredients must exist. So at this point, you can be very firm with it. And this is part of the prompt engineering. If you saw those earlier lessons, is if that first prompt don't work, you can always tweak it and hope for a better result. This is how you could be solving those kind of problems. But I think you get the idea of how we can build a really rich application with various types of input. And you can keep on prompting as you saw, because we have one prompt here for listing the recipe and another prompt for producing a shopping list. So all of these prompts can work in tandem to produce a greater outcome. And you saw how we took all those simple ideas from that first app of telling a fairy tale story to create a more advanced app, including user prompts. And hopefully now you feel like you have an app that actually produces something of great value to you. But just to see if we actually improved things by changing the prompt a little bit, let's see if we can run it again, hopefully with a better result. Number of recipes 1, and let's say I got chocolate and ice cream. That seems more fair, right? And filter is still peanut. Let's hope it produces something that makes more sense this time. So this time around, it's giving us what? Okay, chocolate ice cream sundae. That sounds pretty good. There's definitely no caviar in there. There's ice cream, chocolate sauce, whipped cream, tablespoon of chocolate chips, maraschino cherry. Sounds good to me. Yeah, and we seem to have a bug with the shopping list, but just given the fact that you have a template to work off of already should make it easier for you to get started. But let's just rehash all our winnings today, everything that we learned today. You saw how we built two different apps. You saw the simpler app with the fairy tale. You saw a more fit for purpose kind of application in which we were able to use a food recipe. We used that for chocolate or caviar. So we have everything from dessert to, main meal. Let's just rehash the things that really mattered for you to understand how you can build your own first application using AI augmented within your application. So what was important to know is that keep your secrets out of your code. Make sure that those secrets can be read, for example, from an environment file, and make sure that you use a library like .env to do all that heavy lifting to populate your environment variables. So then when you instantiate up the client, that's made really easy. Once you have that client up and ready, now is the fun part in which you create the prompt, the instruction, the input towards your AI app, and you can give it those messages. So it's either a new conversation or an existing conversation. And as I showed you in the beginning of the video, you can tweak those messages to have the AI assistant be anyone from Abe Lincoln to Gordon Ramsay. So here you can see on line 21 also how we created our first completion. We sent that towards the AI. We got a message back. And thanks to here on line 24, we're able to print that. We also saw in the other example how we could take this and make it really advanced by adding inputs and multiple prompts to create that really great experience, that interactive experience. So hopefully now you all feel very excited about building your own AI apps, whether that app is a space captain or Abe Lincoln or maybe your favorite chef. So good luck with that, and hopefully I'll catch you in another video in this series. Thanks so much.
Hello, and welcome to Generative AI for Beginners. Today, we'll be covering chat applications. I'm Jasmine Greenaway, and let's get into it. First, we'll cover the differences between chatbots and generative AI chat applications. Then we'll talk about building and integrating chat applications. Then we'll focus on options for the user experience and then how to enhance it. Then we'll talk about performance and capturing metrics around the applications. And then we'll talk about leveraging AI responsibly. And then we'll wrap up with a set of demos. So let's start with the difference between a chatbot and a chat application. Both facilitate some sort of communication. Chatbots often follow a set of predefined scripts and rules. And in contrast, advanced chat applications, especially those powered by generative AI, can generate new and contextually relevant responses in real time. A great example of this is when you ask a chatbot something along the lines that's something outside of its domain. It may say something like, I don't know, ask another question, where a generative AI application would ask for more context or provide a best guess. When it comes to building chat applications, it's not always about making them smarter, but also making them performant and a great experience for the user. So let's talk through some options for building a chat application. First is the usage of APIs and SDKs. When you're building an application, one of the first things you're going to want to do is assess what's already out there and save yourself a little bit of time. And APIs and SDKs are a really great first step to leverage functionalities that you don't have to build from scratch. And it also reduces some overhead and speeds up your development process so you can focus on the parts of your application that are the most important to you. Next is enhancing the user experience. And this can be quite important because general UX principles apply, but there's also going to be some additional considerations that become important due to the nature of this application. So adding features that allow users to ask for clarifications, should your chat application generate an ambiguous answer. Also maintaining context, retaining the context so that a user can build prompts based on past information. as well as things like personalization to be able to allow the user to tailor their responses that are the best fit for them. And going deeper into this idea of personalization, you want to tailor the user experience so that the user can receive specific answers that make the user feel good and really just more understood. And last but not least, accessibility. Accessibility across visual, auditory, motor, or cognitive impairments provides an experience that allows your application to be used by everyone. Some things you might want to consider are resizable text, screen reader compatibility, text-to-speech and speech-to-text functionalities, visual cues for audio notifications, voice commands, and simplified voice options. Now, let's move on to another way to apply customization through a process called fine-tuning. Fine-tuning is often considered when a pre-trained model falls short in a specialized domain or a specific task. So things like company jargon, or maybe context around a particular medical condition that a physician is trying to diagnose can fall under this category and are usually great candidates for fine-tuning. Now, the process of fine-tuning requires a data set and an existing pre-trained model, an LLM. And what normally happens is that model is trained with a data set to apply that specific domain knowledge. So let's look at an example of this with Azure OpenAI. One of the first steps in applying fine-tuning in Azure OpenAI is selecting a base model. And this model is what you will train with your training data. And that next step is selecting that particular training data. Now, this is probably going to be your longest step. You might have to clean the data. You might have to format it in a particular way. And you can also refer to the docs on how to do that. But this will probably take a little bit of time to massage the data into a way that is consumable for the model to be used and also to be used effectively. Next, you have the choice to apply hyperparameters. So one of these hyperparameters might be things like an epoch, which defines the number of times that the learning algorithm will work through the entire training data set. And finally, after selecting your data and your hyperparameters, you can now start training that model with a data set. And as soon as it's done, you're ready to go and use this new fine-tuned model. Another option is retrieval augmented generation, or RAG. It's an architecture pattern that augments the capabilities of a LLM, like, for example, ChatGPT, by adding an informational retrieval system that provides grounding data. And adding this system gives you control over grounding data used by an LLM when it forms a response. Now, here, what we're looking at here is like a diagram of this particular architecture using Azure services. So in here, we have Azure AI Search and Azure OpenAI. And this architecture diagram isn't like every RAG architecture, but it really provides a really great high-level summary of the pattern. And basically how it works is that you would start with a user question or request, also known as a prompt. You would send that to something like Azure AI Search to find relevant information. And then you would send the top ranked search results to an LLM. And finally, you would use natural language and reasoning capabilities of the LLM to generate a response to that prompt. So let's start applying these steps onto the architecture diagram that we're looking at right now and map them to the services. So the web app on the left here provides the user experience. So the user will essentially ask their questions or prompts there in that particular app. Now the code in the app server orchestrator coordinates the handoffs of the user experience between the informational retrieval and the LLM. So essentially Azure AI Search and that large language model that might be in Azure OpenAI. So inputs pass through here to get search results through a query, but also go to the LLM to set the context and intent. So that query in Azure OpenAI Search or Azure AI Search can really handle the keyword or term or vector queries. Now, the LLM receives the original prompt plus the results from Azure AI Search. The LLM will analyze them and essentially formulate a response that goes back to the user. Now, Azure AI Search provides inputs to the LLM prompt, but doesn't actually train the model. And this is really where it deviates from fine-tuning. So in RAG architecture, there's no extra training. The LLM is pre-trained using public data and generates responses that are augmented by information from the retriever. And you can learn more about this pattern in chapter 15 of the curriculum. Now, we'll move on to considerations for a high-quality AI-driven chat experience. We'll look at performance metrics and how to use AI responsibly in these sections. So numbers matter, and it's essential to keep track of metrics like response time and user satisfaction to make sure their application is performing at its best. So considerations for performance metrics fall across time, accuracy, user perception error rate, and anomaly detection. And time is usually one of our most valuable resources. And one of the things you really want to consider is how long does it take for a user to get the answer that they're looking for? How long does it take for your application to run successfully? Measurements like uptime and response time fall under this category. Another in consideration is accuracy. And metrics like precision and recall that also create what is known as an F1 score can be helpful here. Moving on to user perception, this can really come from a number of different sources. For example, surveys, user interviews, or user studies. And the important thing here is what will you do with the feedback and how will you apply it and integrate it into your chat application? Another consideration is error rate, or how often the model makes mistakes in understanding or its output. And finally, anomaly detection, or identifying unusual patterns that don't conform to expected behavior. And one of the things you might want to consider here, and really all these metrics, is how will you respond to these? Another component for a high-quality chat application is using AI responsibly. And Microsoft has an approach to responsible AI that is split into 6 principles that should guide AI development and use. It's important to build trust and inclusivity amongst your user, prevent harm, protect their data, as well as provide improvement and corrective measures in case of mistakes. Let's take a look at some demos. The first demo I'm going to show you is a basic usage of the Azure OpenAI endpoint in the Azure OpenAI service. So we're in a .NET Interactive notebook. And what we're going to be doing is bringing in 3 libraries here: Azure OpenAI, SDK, as well as system environment for some configuration steps. So I've already brought in my endpoint and my key, and I'm just going to go ahead and click these cells and go ahead and click on this cell. Before I do, I just want to kind of walk you through what's happening here. We're sending in a system prompt that says that you're a software engineer at the end of your day, and the user or the input that's going to take in is what tasks need to be doing. So essentially, this application is a software engineer finishing their day, and they need a task list of what to do at the end of their day. Now in Azure OpenAI, you deploy your LLMs and you give them a label. And so that's what's happening here on this line here, where we're called get chat completions. And so we are accessing the chat completions model, and this is essentially chat GPT 3.5 Turbo, and we're accessing it to complete our message here and our input and respond to our input. And there we go. So here are our steps that we need to do to wind down for the day. Now that was a really basic example, but now I'm going to show you a little bit more of an involved example of a .NET application that has a basic chat app here. So let's go ahead and ask the chat app, what is the highest point of NYC? And we immediately got a question or answer or response back saying the highest point is in Staten Island, reaching an elevation of 410 feet or 125 meters above sea level. And as we can see on the left here, kind of how similar how you would see this in ChatGPT, it actually summarized. We actually use Azure OpenAI to summarize the conversation that we're having on the left side here in our chat history. If you're interested in learning more about building chat applications with generative AI, or even learning other topics, visit our curricula listed here. In the curricula, you'll find more in-depth information about this topic and many others, including interactive notebooks for you to try out for yourself, like the one you saw here. Happy learning.
Okay, welcome to this session for generative AI for beginners. My name is Dave Glover. I'm a cloud advocate. I'm based in Sydney, Australia. And this is for lesson 6, building search applications. Alrighty, so what we're going to cover in the session, we're going to look at what semantic search is, a term you might have heard bandied around. We're going to talk about vectors and embeddings, again, a term that you might have heard, but just kind of what the difference is between them. We're going to talk about vector stores, and we're going to cover demos. So the goal of this session, so ultimately at the end of the session, you're going to have a better idea how vectors play a crucial role in enabling effective semantic search. So hopefully that's what you're going to pick up out of the session. Now, when I first started talking and learning about generative AI, one of the terms that was bandied around a lot was semantic search. And I must admit, at the time, I didn't really know what semantic search was. But a bit of digging around, I kind of got the general idea of how this works, and hopefully this will help you as well. So semantic search is really kind of intent-based search, or boiling down to what are the core concepts you're thinking about and you want to look for. So take an example. If you talk about my dream watch, now if you did a keyword search, you would end up with results which were about dreams and which are about watches, which is probably not what you were looking to find. Now, if you were doing semantic search, what that would do is that will boil down to the concept probably of my ideal watches, which is what you're really thinking about. And then you'd find things about ideal watches, and you'd probably expand on that search term. So the key thing about semantic search is around intent, or around the concept that you're looking for, as opposed to keyword search, which would find dreams and watches. Now, semantic search is kind of like a really pivotal point or pivotal concept when it comes to building large language model applications. And you'll often find these applications take a big dependency on what we call semantic search and embeddings. Okay, so you've heard about the term vectors. No doubt you're learning about those in university or school. And you might have heard the word embeddings. You might be thinking, well, what's the difference? Because often they're used almost semantically, almost hand in hand. So vectors and embeddings, what are they? So an embedding is a special type of vector that is generated by a large language model that has semantic meaning. So ultimately, what it's going to generate, when you go and send a piece of text off to an embedding engine, it's going to return back a vector, and that vector will have a representation of what the semantic meaning was of that bit of text you sent into that embeddings engine. Now, there are lots of different embedding models. Now, the ones you've probably heard of would be like the OpenAI embeddings model. So there's text embedding 3-small, which is a new model that's just come out. -3-large is again a new one. You might have heard of text embedding Ada-002, which has been a very popular one. Now, these are by no means the only embeddings models. So if you go off to Hugging Face, you'll find a whole series of embedding models, and you'll find rankings of performance and how well these things do. But to give you an example, and in fact, for the example I'm going to be showing you, the example in this lesson plan, it's using text embedding Ada-002, and it will return back a vector, which is 1 by 1536 dimensioned vector. So that's what you're going to get back. And obviously that's pretty difficult to kind of visualize, and you can't really imagine what that is. But anyway, that's the size of the vector you get back. Now, the other concept that you'll often hear bandied about when it comes to vectors and embeddings is around this concept called nearest neighbor search. And what that's doing is that you've got a collection of these vectors which have been created using these embedding models. And what you want to be able to do is you want to say, okay, well, I've got this collection of embedding models. Now I want to go and find, I've got another piece of text. This is my search term, my dream watch, for example. And I want to go and find in that collection which of the vectors are closest to this concept of my dream watch. And this is the concept you hear called nearest neighbor. And you'll also hear the concept of cosine similarities. And cosine similarities is a formula that you can use across a collection of vectors to go and find a vector which matches closest to the vectors in this collection. And basically calculates how close one vector is to others in multi-dimensional space, in this case, 1 by 1536 dimension vector. And basically what you get back is you get a ranking of relatedness of vectors or semantic meaning against your vector that you're looking for. Now, to kind of visualize this, if you think about, most of us, we can happy with 2-dimensional vectors and 3-dimensional vectors. So you think about, we've got on the left-hand side here, we've got 2-dimensional vectors, and we can see here, okay, well, I've got this blue dot here was the vector for my search. Well, you could very easily say, well, okay, these other vectors around here, these points that represent these vectors, you can see they're close. But you can see this black dot over here and this blue dot over here, they're not so close. So you can see that if you were to do a cosine similarity, these dots here would be closest. The same thing here in 3-dimensional space. Now, I'm using an application called Octava, which is quite a nice application for just visualizing things. And you can see I've got 10 vectors here. And we'll go and run this. And just to help visualize this, so we just move this around, you can start seeing, well, I've got these vectors in 3-dimensional space. And most of us, we can see X, Y, and Z. And we can visualize that pretty straightforward. And again, if I said, okay, well, this red dot here, this was the red dot that represents my search question, the vector that I want to search for, you could see around here that, okay, well, you can see that these dots here are most likely related to the red dot in the center. So kind of you can, again, visualize this. So we can visualize 2-dimensional space, we can visualize 3-dimensional space, but clearly we can't really visualize too much more than that. We certainly can't visualize a 1 by 1536 based vector. So hopefully it kind of gives you a bit of an idea, and you can just kind of extrapolate that concept of saying, okay, well, I can understand 2-dimensional, 3-dimensional. There's a formula which can help me go and work out what it would look like, what would be the nearest neighbor using cosine similarity. Now, what you find is with, again, this concept of vectors and embeddings, if you were to go and create an embedding for boots, shoes, and socks, they will create vectors which are in multidimensional space related. They'll be sitting in the same multidimensional space. And over here, the concept of a camera, well, that's not the same concept as shoes, socks, and boots. So it's going to be in a different dimensional space. So again, when I said I want to go and buy some shoes, for example, might be a query, you would create an embedding for that, and then you would go and search across these vectors, and you'd find, okay, well, these shoes, socks, and boots would be the closest vector in multidimensional space. Hopefully that was clear what's going on. Okay, so the next thing I want to talk about is that we've got these vectors that we've created from embeddings, and we want to store them somewhere. So you'll hear about vector stores, and these are just effectively like an index or like a database, but they're optimized for storing vectors. So you hear products like Azure AI Search is a vector engine, Redis, Postgres, Pinecone, and there are a lot of others out there. There are about maybe 20 or so vector stores out there in the marketplace today. But again, the popular ones are things like Redis and Azure AI Search. Now, the demo that I'm going to show you, and a great way of prototyping some of these things, is actually to do this just in memory. And a super easy way to do this was just with a pandas data frame. And this is what the demo that I'm going to be showing you, and the demo that you'll find in the repo, is rather than having to worry about back-end data stores for prototyping and just playing around with ideas, a pandas data frame is a super easy way to get up and running with this. But clearly you wouldn't do that. If you were pushing this application to production, you wouldn't run this application from a pandas data frame. You would use some sort of back-end data service like Azure AI Search. Okay, so we've got a bit of a demo, and I just want to show you a bit of how this works and how this data set was built. So the example that you're going to find in the repo for this talk is actually taking the transcripts from a whole lot of YouTube videos. It's actually content from the AI Search, the Microsoft AI Search channel, which is on YouTube. And what we did is we took around about 300 transcripts from various talks, and we embedded those. So we created embeddings for them, and we put them into, in this case, into a pandas data frame, and we can use that for searching. Now, I just want to talk a bit about the concept about what you do around this. So you've got this transcript. Now, whenever you've got large data sets, it could be a transcript, it could be a PDF document, it could be data from a Word document, or wherever this bit of text is coming from. What you typically do is you break that down, or you do this concept called chunking. So you take this video transcript in this case, and what you do is you chunk it down. And the chunks are kind of, the way you think about this is what fidelity do you want for the search? Do I want to be able to search in 5-minute increments in that video transcript, or 3-minute increments, for example? And that will determine how big the chunking size is. Now, the other concept you do with chunking, and again, you'll find various libraries which help you with chunking, is you also tend to do an overlap. And the idea behind this is often it doesn't make sense just to cut off a chunk at an arbitrary sentence or things like that. You might say, well, I want a sentence or two from the next chunk. And that kind of gives you context, gives you kind of better context. And you can see in this chunk, these chunks here, I've got a bit of, you can see this red text here is actually the beginning of the next chunk. And again, you'll find that there's a second chunk down here. The red text is the beginning of the next chunk. And again, that's done to provide better search, semantic search. So then what you go and do is you go and send each of these chunks off to an embedding. In this case, we're going to send it off to text embedding ADA002. That's the model we're using. And that's going to return back a vector. Remember, it returns back a 1 by 1536 dimension vector. And then what you do is you put that into a store. Now, in this demo, what the store is actually just going to be a JSON file. And we're going to load that up into a pandas data frame. So now I want to go and search. Okay, in this case here, I want to go and learn, I want to learn about RStudio and notebooks. So remember my data set was the AI show, and it's going to have lots of content around Azure and notebooks and Jupyter notebooks and cognitive services and things like that in RStudio. But I want to find particularly around RStudio and notebooks. So the way you do that, that's my query. And then what I would do is I would generate an embedding for that query. So again, I'd send that bit of text off to the in this case, text embedding ADA model, and I get back my 1 by 1536 dimensioned vector. And then what I would do is I would do a nearest neighbor or cosine similarities against my store. Now, backend data systems like Redis and AI Search, they have the capability to go and look at vast amounts of vector data and then find the nearest neighbor. That's kind of what they're optimized for. We're going to be using a pandas data frame, and we're going to be using cosine similarities. And then we'll go and do that. We'll go and find the closest vectors which match that data. And I get back the results, and you typically get back a ranking to say, okay, well, we think this is 0.094, 95% closest ranking. And again, you'd see various rankings of the chunks of text that most closely match by semantic meaning the result set in the data set. Okay, so hopefully that was fairly clear. So what I'm going to do is pop across to Visual Studio Code, and in the repo for this lesson, you'll find there's this Jupyter Notebook. And what this Jupyter Notebook is going to do is going to load up various things, but the most important thing about, well, the couple of things that's going on here, we're going to be calling the OpenAI text embedding ADA model to go and generate an embedding for my question, which we're then going to use against the sets of embeddings for the transcripts. Okay, so the first thing we're going to put up the endpoint. We've got the API key, API version. This is just information that's needed for Azure OpenAI. And then I'm going to say the model is text embedding. Now, it's super important that when you're going to embed your question, you're using the same model that you use to create the vectors for the transcripts. So those models are going to match. And then this is the data set that I'm going to load up into memory. Now, I'm going to skip through some of this reasonably quickly. You can go and look at this in your own time. But here goes a function for the cosine similarity. And there's a NumPy formulas in here for working out our nearest neighbor. So we're going to come through here, and ultimately what this is going to do, we're going to load up the data set, and then we're going to sit in the loop, and we're going to ask for a query. And so we're going to run this. So we're going to run this Jupyter Notebook, and that's loaded. And it's going to be, I'm interested in talks about RStudio and notebooks. Okay, so that's going to be my query. So that's a question. So remember what's going to happen. This is going to be sent to the embedding engine. And what it's going to do is create an embedding for that. And it's going to go and check all of the embeddings that I've created for the transcripts. And it's going to bring back the videos that are most similar. And a nice one that I've tested out already is in this one here. So the second one here, data science with machine learning. In this video, Rafael is going to talk about data science and machine learning. And you'll see the similarity is 0.84. And if I go and click on this link, what you're going to notice, it's going to start talking about, it's going to take us straight to that transcript and to the place in the video. So you see what happened there is that I'll just go back. We'll click on that link. So you see the beauty of this is taking that complete transcript, we chunked it up into, I think, 3-minute chunks. I did my query, I converted that into embedding, then I looked across my pandas data frame, I looked at all of the embeddings or the vectors I've got sitting in there, I found the closest, and inside that data set, I also had the time that said, okay, they're going to start talking about RStudio and notebooks at this particular time in this YouTube video. So that's kind of how this works. So hopefully that makes sense and gives you a bit of an idea of how the application works. Okay, so with that, we've got a couple of resources. So we've got the search application I've just shown you. So you'll find that link in here. So you'll find that. And there's also a really good set of Microsoft Learn content, and a particular one there about understanding embeddings in Azure OpenAI search or service. And then have a read through that. Again, you're going to learn more, but hopefully that's giving you enough to get you going and learning about how to go and build search applications using embeddings, vectors, and cosine similarity, and using nearest neighbor to go and find the relevant content in your data sets. Okay, thank you very much.
Hey everyone, welcome back to Generative AI for Beginners. I said I would be back. I am Pablo Lopez, cloud advocate in AI and a little bit of .NET, and we have Chris Nori. I believe you folks know him by this point. Say hi, Chris.
Hey folks, super excited to be back. My name is Chris Noring. As Pablo was saying, you might have seen me in a couple of videos already, hopefully. I'm a senior advocate at Microsoft, and just like Pablo, we do awesome things with AI and many other exciting technologies. Back to you, Pablo.
Thank you so much, Chris. And you know what? That's why I was really excited with generative AI, because I know you folks already seen a lot of text, right? So you folks saw me on lesson 2 talking about how you learn on LLMs, foundation models, the very basis on Azure AI, but now you folks are more advanced. I already saw a little bit of, chat applications, text applications. Let's go to images now. So What we're going to cover today? We're going to show image generation and how to use and build an image generation app. You see, just two things here, but I have to a little bit do some explaining because image generation is a little bit more complicated than, what we usually saw a little bit on text, right? So let's build an image generation app. We're gonna prompt engineer for image generation and work with DALL-E and Midjourney. But not only those two, I'm gonna talk that a bit later. So let's start with a single question. How? Right? Because if you folks saw on the last episodes, you folks may know that I can type and then it can, try to tokenize, right? Try to generate next token to finish. But images do not work like that, do they? They have pixels, they have RGB values, right? So it sounds a little bit confusing on how those can work when it sounds like magic, right? So how to generate images with AI anyway? So I'm gonna start talking about one thing. Remember what I said about foundation models? They are trained in a multimodal way. So they have not only text, they have text, images, videos, music. They have a lot of things to train them. So one cool thing that happened is that they try to do OpenAI has Clip. So what is Clip? Clip is basically you get images, and then they're gonna try to classify it. So here I have one of the tests I did with Clip. So it's Food 101, which is a small data set for testing. So you can see here we have a very fancy guacamole, by the way. Look how fancy it is. And you can see that it can rank perfectly on that. Of course, not always is going to, be exact. Remember, generative AI has a lot of statistics and can be a little stochastic. Sometimes get things a little bit wrong, but you can see that was a major advance. So what a good thing about Clip is that it is a generative AI that can describe images very well. So it can get images and think, I believe this is that, and this is how it is, blah, 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 blah. So you can see it can be very descriptive as well. Okay, Pablo, great. Now the generative AI can describe images. Cool. How are you saying this is great? Because imagine the following. Remember when I talk about embeddings? Yeah, baby, embeddings. So what can it do? It can pick this text and generate embeddings, right? And then I know if I can do text, I can describe it. How can I do the reverse? So imagine that Clip, instead of, trying to describe something, you generate something with embeddings. And then I have a neural network with, attention, diffusion, all the amazing things that we have with generative AI. It could actually, go back into the reverse process. So that's what it does. So Clip gives, a vibe, basically. I like to say a little bit Gen Z, right? So it picks the vibe of the image, say, this, I believe, should be the vibe. Then when you type, you're going to have something that you want to describe, right? Imagine that I want to describe a dog in the Eiffel Tower. So it will have Eiffel Tower, it will have dog, it will have some, it will have something that you can think about, something you can imagine. So what it does is basically pick that, turn it into embeddings, and then Clip can judge, right? Clip can judge between the images that you have and the image that they generate. So that's how they trained this model here, this attention model, to create images by your text. Because we had a Clip, so we could just always compare. That's amazing. So then they created this. So it's two parts, basically. Clip, which communicates and can judge and can say things, and I have this diffusion model right here that can generate images via text. So that's how they created those amazing AI models that you know today with images. But okay, we have now so many, right? I just pick 4 here. DALL-E, which is from the OpenAI family, GPT family, you folks already know and love. Web Copilot, that we had a lot of, DALL-E uses. So if you want to test DALL-E, the best way and the quickest way is to go to Web Copilot on Bing or Edge. We have Midjourney, which uses the interface of Discord servers. It is it can have some limits, and you can have Meta AI, which is not available right now for most countries. But then we have Meta AI. Meta AI is basically the meta version of DALL-E. Of course, they teach you a lot of things, they can talk, etc. So they have inside of it a generator model that can generate images. So, and these are just four. We have so many to describe from, but these, as I know, are the most used. Of course, you can use Stable Diffusion, you can use your own computer to do that, as we talk on service versus model as well. It's the same things you can think about on here. So there you go. Now, why to generate images anyway, right? So you may think, I don't have many uses for that, Pablo. Why should I care about those? And here's the thing about it. It is a fast way to prototype anything. Imagine that you're doing an app and the design team is not ready. You can actually do a small logo just to test, and then try already with specifications to do and create things faster. So you can prototype, and then when the design team is ready, you just change and done. You already have your feature ready. Or if you are, a company, you're just you don't have budgets to contract them. So we can actually try to generate a lot of with AI, just do tweaks here and there, trying to understand a little bit more to help your UX to glow up. So these are some amazing things that we have with generative AI. It empowers people that don't have, sometimes the knowledge to create great things, and then try them to improve on those to make excellent concepts. Or you can try to prototype fast to deliver things on time. And not only that, you can use them to scale as well. So we have three amazing things that you can do with images with generative AI. So I'm gonna bring Chris. Chris, man, what do you have for me today?
Right. So what we're trying to achieve today is to make sure that you understand when you're supposed to use image generation, right? Because it sounds super cool. Even with text generation, you send something to an AI, you get some interesting response back. In the case with text versus text, that's fun, but even more fun is if you can take that text prompt, that prompting knowledge, send that into the AI, and out comes an image, right? And now you've already shown, Pablo, how we can get some really exciting images with space or landscape or what have you. All of that sounds super nice and neat, but what if we had a customer scenario? Because I can imagine that many of you are watching this, and maybe you are senior developers or some kind of enterprise developers, or maybe you're thinking about a startup, and it's like, how would I use image generation in a business scenario? So that's what we're trying to do here today. So what we're going to do is, me and Pablo, we're going to play the role of a customer. That's going to be me. And Pablo is going to be the developer who's going to interview the customer, namely me, and see what I want. And just for the sake of scenario, I'm going to play a property manager in London, right? So I'm going to be that customer. I want Pablo's help as an engineer to use image generation to improve my business. So Pablo, I'm going to let you take it away from this point so you can start interviewing me so I get what I need.
Chris, hello, what do you need today?
Hey Pablo, it's good to meet you today. It's going to be exciting to see if we can work on a project together so you can help improve my business. But today I'm going to be a property manager. I'm based in London, so I'm going to need help with all my properties to make sure that we can sell them or sublet them to whoever, my customers might be. But one of the problems I struggle with, right, is to make sure that I can visualize things to people, because sometimes I have a photo, sometimes I have not, and I'm not even sure whether photos make sense in the evening light or the morning light. So I think I want some kind of AI service with image generation that can really help me think like, is this what I want? Is this not what I want? So maybe you can help me based on the context of this being London. What do you think?
Absolutely, Chris. So we can actually generate some images to at least prototype what you see in your vision. That's a very good part of generative AI. Generative AI can do a lot of those things to help you. So what kind of properties are you thinking about?
Yeah, so I usually have a lot of properties by water, so it would make total sense maybe to say, hey, let's go for London properties by water. I mean, of course, I'm going to have some high-rise buildings, some smaller buildings, but I'm just curious to see what at this point what this tool can do for me. So maybe you can show me based on that info.
Absolutely. So we can do a very basic prompt right here, which is properties in London by water or comma river here. So you can actually start to generate something. And that's a thing that I'm going to show you on Azure AI. So you can see that we have settings, but first I want to show you that it's generate one image by prompt on Azure AI. I want to request more. You're going to see later how to do that. But you can see right here you have some options. So you can copy prompt, generate the images of the same prompt, download, show code, or delete. Right here it shows that it succeeded, which is great because now it's going to handle our image here. And while that shows, there we go. This is the image that is generated. But I want to show you as well, folks, some things on daily settings because, yes, we are not just limited. Imagine that you think, oh, this is too vivid. This is so dreamlike. How can I be more realistic? You can change on prompt, sure, but you can change here on our style image. So it can be like natural. I want the quality of image in HD. And let's be with the classic, the square one. Okay, Chris, I generated some images here. An image. What do you think about this? What do you want to change something?
So looks pretty good, right? I mean, it's by the water, it kind of resembles the building that I do sublet or sell. What I'm a bit curious about, if you can show this in a different light, maybe, because this looks like evening, and I probably want to show it in the morning light, I think. Like, it's always nice to have both, right? Because people want to see that nice lighting in the dark, but if I can have some reference image with morning light, I think that'd be great.
By the morning light. So you see how I'm doing here, right? So basically, I'm trying to describe what Chris is feeling. So, and you may be asking, okay, but comparing to what I wrote on an agent, Pablo, what is the difference? So on images, usually you have to be more direct. You need to imagine being a director, right? So you have to imagine where you're putting things or trying to understand the lighting, the composition. You need to understand if you're going to use lenses, what kind of lenses are you using? Yes, that's important as well. So you have so many things you may think about when you try to write a prompt, but it's different, a lot different than you try to write, for instance, on text, because text is, you're an AI agent, you do this, that, this is how you do it. No, here you're being more like a director. Imagine that you have a camera and you can try to put things here and there. You can change lighting, so have a lot more flexibility here. You don't need to, instruct what it needs to do, like, you're gonna do this and that. Try to be more, take some liberties on here as well. So there you go. I added here by the morning light and see what it generates. And while it generates, I can show you as well some things. I can copy this prompt and I can generate new image. So you can see right here that I'm generating another image with the same prompt. And let's go for easily download. But I want to show you more things. Very soon I'm going to show you the code. And there you go. It's already generated both of the images. There you go. This is properties in London, by the water, comma, river, by the morning light. What do you think about those two images, Chris?
Yeah, I especially like the middle one. It actually looks like one of the properties that we are selling right now. So what I am curious about also, because we need to be able to feature this at various web pages, mobile apps and so on. So are you able to show this in different resolutions? Like, could I have like a mini map or no? The word I'm looking for is thumbnail. Like, could you make a thumbnail out of this and maybe a screen resolution that's quite big? So I'm kind of wondering about the flexibility here.
Absolutely. And I'm gonna tell you one thing before that. You notice that I already changed some of the settings here. Remember, I already changed it from Vivid to Natural and to HD. And I'll show you what the same prompt does with different properties. So this is with Vivid and Standard. Look how different it looks with HD and Natural. You can see that it's trying to be more a photo than trying to fit on the properties. So you need to make sure that you're fitting on the properties. And you can see right here, this looks much more natural, right? Doesn't look like a painting or something like that. Of course, the water maybe, but you can adjust on the prompt as always. So Chris is asking, can I generate different sizes? And for sure, let's go to a bigger size. Let's imagine that we need to a banner for a web page. So let's generate on a big size. And then let's generate, in a tiny bit, like 256 for 256, like very small. So yeah, you can actually right now, I'm trying to generate more images and, oh, okay. I love when this happens. There we go. Okay, let's go to got that basically. Okay, so you can see right here that now I'm generating my banner. So the banner is generated. And may ask, Pablo, I didn't like this angle, right? It doesn't look what I'm thinking that this should be. Don't worry, you can try or to generate new image with the same prompt, or you can try to do a little bit. I'm gonna show you. Not gonna show. Pablo, I didn't like the image. What can I do? Let's pick this one. I don't like the sky. So what can we do here? We can try to mask or try to regenerate images. Pick the best ones and then try to see what you have. Remember, generative AI is a little bit, stochastic in how to generate images. So sometimes not generate great things. But look at that. That looks stunning.
Yep, for sure. Yeah, I really like that image. So I was also thinking, like, a lot of the objects we sell are like apartments, right? So wondering if you can be flexible to do like townhouses, because we have those too.
Oh, excellent. So then, folks, what you need to do is that properties in London, right? You can describe here inside of it. So let's go with properties in London, properties with townhouses. There you go. So you may ask, Pablo, this is not the most, sometimes correct way to describe. And yes, but remember, technically, you can just put more and more and more. Sometimes we take care of how we put the order of the words, but connectivity and sometimes even when you try to write the most grammatically correct, doesn't, allows DALL-E to optimize by the prompt. Remember, you're trying here to optimize to DALL-E, not, in a way that's right. So properties with townhouses sounds strange, but sometimes it's the best way because I understand that you can mix other properties with townhouses, right? We're trying to attach here the meaning of both. Yeah, classic generative AI. You need to learn some small tricks here. And let's talk about a little of the prompt. You can see here that it's our properties with townhouses. And you may ask, that doesn't seem that correct grammatically or stylistically. And that's true. But you may think one thing is that sometimes you need to prioritize the way that you word for DALL-E, not to make the most sense, but try to make like weights into the prompt. Imagine that you're not putting like a prompt, like a very defined sentence. It's more like trying to DALL-E to understand, okay, what is the weights you should put here and going here. So we have properties, of course, it tries to put houses here. And that's the thing. Sometimes it'll hallucinate. But if it tries to hallucinate, okay, let's get rid of properties and then just do townhouses. And that's the thing. You need to tweak a little bit here and there to try to get the best image. But I'll be very honest, this one, stunning.
Right. So thank you for this one, Pablo. I think we're going to close down on our customer scenario here, but I think it's pretty clear that, you're able to deliver different kinds of light, different kind of buildings, maybe different angles, and exactly what you showed, right? I mean, you just need to adjust the prompt and you can even change the size of the image for thumbnails, for larger image. Ooh, that looks pretty good.
Ooh,
so let's take it home, Pablo. Let's see if we can summarize this video. All right.
Absolutely. But before I summarize, you may ask, how can I implement this in my applications? So if you have some doubts, take a look on our guide here, Building a Generative AI Application on Lesson 9, or take a look here. We have some documentation. So here's Python, but as always, you can select multiple things. Then you're gonna have your client, your API version, your endpoint, and your API key. Remember that you need to generate with prompt right there. and then you're gonna have n. N is number of images generated. As you folks see, I'm generating one per one, but you remember if we generate for Dolly or Midjourney, you have multiple. So you can just put n equals number you desire, and then you can analyze image by this image URL. More things. Then how to generate Pablo? I love that. I want this exact thing. You can first click code, and then you can understand how to write this prompt, and then the JSON loads. But let's recap what we learned today. You understood how Dolly and Midjourney works. You understood how many opportunities that we have, and you understand how to apply those. You got to hear me and Chris talk a little bit how to do prompt engineering and how to put that in your code. Folks, that was a great lesson. Thank you so much for being with us on Gen AI for Beginners. And Chris, last words.
All right. So thank you so much, Pablo. And all of you out there, I hope this was an interesting lesson on how to work with images and especially how you can generate those. Exactly what Pablo said. A little bit of prompt engineering, a little bit of tweaking, and you can see vastly different results. So you saw how flexible that was. You saw how easy also it was to use some Python code, whatever kind of code to integrate that into your app. So definitely use the studio to get that help, but there are also some great tips on Microsoft Learn and Microsoft Docs pages, and also some sample repos out there, and definitely our own curriculum, Generative AI for Beginners. So thank you for watching.
Thank you, folks. See you next class.
Welcome everybody to the Generative AI for Beginners course. My name is Somale Zadigo and I'm a cloud advocate at Microsoft. So today I just want to showcase lesson 10, building low-code AI applications using generative AI, which you probably didn't think it was possible. So this is also part of the Generative AI for Beginners course. And for this lesson, we're going to be covering a few things. So we're going to cover how you can use generative AI in Power Platform, and then we're going to switch over to look at the AI capabilities with AI Builder and generative AI. So it's not going to be just only purely based on generative AI. We're going to look at some models that come with AI Builder and also Gen AI within the Power Platform. So the generative AI in the Power Platform is actually about enhancing low-code development and application with generative AI, which is a key focus area for the Power Platform. The goal is to enable everyone to build AI-enabled and powered apps, sites, dashboards, and automate processes with AI without requiring any data science expertise, whereas in the past, you needed to have a technical background or become a data scientist to actually work with AI. And like I mentioned, we can empower every person with AI because AI is no longer a niche capabilities for pro developers and data scientists, which we can provide through Azure. AI is an imperative and expected offering in our day-to-day productivity. So you can think about PowerPoint Designer, for an example, in which in this case, when you are working on those slide presentations, you may have some suggestions for how your design would look like for a specific slide on your deck. And also, you can also have Teams transcriptions. So you record a Teams meeting, and then you can be able to pull a transcript from that specific Teams meeting and hear what other people were saying if you couldn't make it out on the audio. And of course, the new Copilot capabilities in Microsoft 365. But before, we actually had like technical workers that worked with AI through pro-code development around using Microsoft Azure and some of the cognitive services within Microsoft Azure. But now, the making experience in the Power Platform as part of the Microsoft Cloud offering takes the same principle of bringing AI capabilities to aid every makers in our platform. Being able to build solutions that are AI powered and also AI enabled so that they can be able to build those solutions. Either you are sitting in an HR department or a marketing department, you can use low code, no code tools such as the Power Platform so that you can be able to ship your solutions to your everyday end users that are in a sense using Microsoft Teams, Microsoft 365, and also SharePoint. But low-code, no-code tools like the Power Platform are not necessarily familiar with a lot of people. And you might be asking yourself, what is the Microsoft Power Platform? Well, this is where no code, low code, and code first is welcome. So this is where you can be able to build solutions without needing to have any knowledge of how to write a program or how to write code. But again, even if you know how to do that, you can be able to bring those experiences into the Power Platform and build solutions that are already enhanced with some of the skills that you already have and also the new capabilities that you can have. The Power Platform is actually made up of 5 products where you have Power Apps for mobile development, mobile app development, Power Automate for process automation, Power BI for business analytics, Copilot Studio, which is my personal favorite, where you can build your own Copilot. Power Pages, lastly, where you can build externally facing websites. And all of these have a generative AI capability enabled for them. And this is Copilot, where you have the Power Platform Copilot that enables you to build even faster solutions using each or every single one of these products within the Microsoft Power Platform. But how does this actually fit into the Microsoft Cloud? In the past, because of the fully integrated Microsoft Cloud and our investment in Azure or in OpenAI, we're able to apply generative AI, which is large language models, into the fabric of each and every single one of our products. So you can think about, for an example, Microsoft 365. Now we have a Microsoft 365 Copilot that enables and enhances productivity. There's also Copilot in developer tools in the form of GitHub Copilot, and you will have either your IDE or you're using your code editor like Visual Studio Code to actually write code even much more faster using GitHub Copilot. Even the Power Platform has its own Copilot that like I actually mentioned earlier on. So Copilot is about making AI a companion to help you do your job better and faster. You can think of the era of Copilots rather as having AI as a real-time collaborator that generates content, sparks creativity, and completes work. But then how do you then take advantage or positive advantage of generative AI within the Power Platform? How do you use Copilot to enhance your productivity when building solutions? Let's take this example for a moment to actually look at how you can be able to build an automation much more quicker than you would have in the past. So we just describe our automation and say on a daily basis, we want to collect all the performed inspections from Power Apps. And we have a condition here that says all those that have paused, compose an email summary and attach an invoice from SAP. In the past, we would need to add the steps manually, but with the help of generative AI in the form of Copilot in Power Automate, we have a Power Automate flow already built as a draft. Then we can be able to see some of the actions that are already added. So we retrieve an invoice from SAP, add generative AI capability by generating an email body, which we'll get to later. And also, we need to make sure that we enforce responsible AI where we review that email message that was generated by AI. Then after we've approved that, we send an email to that specific party. But then in a sense where you actually want to update this draft using generative AI instead of using the manual process as we would have done in the past, we can still use or take positive advantage of the chat-enabled Copilot within the designer or the design studio within Power Automate. So let's say we have another condition now into our Power Automate flow that we actually want to cater to. So we look at if the car has been inspected, we want the bot to check if the car has been inspected and is off brand. Then after that, it needs to send an alert to a Teams channel after that specific inspection has failed. So what then generative AI does, it actually adds those actions in that very specific place so that you can be able to put in all of those details that you actually need. And then you can even see, even with this capability, you can also add in some of the other conditions where it checks for if the inspection has failed. And if it has, it posts that specific Teams message onto that specific Teams channel that you are specifying within your Power Automate flow. But then again, is that it? Is it really that much that you can be able to use generative AI like that within the Power Platform? No. Let's actually look at how you can use other AI capabilities within the Power Platform by looking at the AI models and Gen AI with AI Builder. Firstly, let's look at AI Builder. It actually enables you to infuse AI to turn data into actions without writing any code. So you have a few different capabilities in this case where you can look at documents, where you can process some of those documents. Either you want to process a form, receipt processing, or you want to do some language detection, text translation, and also category classification and so forth. You can also take it a step further and work with images where you want to detect some objects within a specific image. So you can use the object detection model within AI Builder, or you can use the text recognition OCR. Then it doesn't end there with AI Builder. You can also make decisions by using the prediction model that AI Builder is actually enabling you to use. It doesn't end there. But the biggest question is, okay, this course is about generative AI, and we're just only talking about AI models that have already been there even before generative AI came into play. And this is where we actually look at how AI Builder and Dataverse ground, secure, and integrate business data with AI. Through this, Dataverse has your knowledge, you have all of your information stored into a Dataverse table, and then you want to actually be able to access that and utilize that knowledge into some of your solutions using prompts. And that is done through AI Builder. And within AI Builder, we have something called the Prompt Builder that enables you to either use or create your own custom prompts that you can be able to put into some of the solutions that you have. So you'll have a pre-built prompt library that has templates to leverage models and prompts without any training required. Then if you don't want to use a pre-built prompt library, you can also use or create your own custom prompts by using the prompt engineering interface within either Power Apps or Power Automate. So you can build your GPT prompts that trigger instructions on GPT model hosted in Azure OpenAI service. In this case, you don't manage the models in the Azure OpenAI service, you just consume and build your own custom prompts using the prompt engineering interface. Then last but not least, you can also add your data into some of your prompts. So you can cater for your data in some of your prompts where you add dynamic inputs. For an example, data from an automated workflow and also enterprise data to ground your prompts. Let's look at some of the scenarios that are available with the prompt builder. You have summarization, which is the most famous one, where you can have some text summarization, either from an email. You have text classification, you have content generation, and email reply. You want to be able to reply to an email or have help from generative AI to help you reply to an email instead of having to sit there and think about how you can be able to draft. This email reply capability, for an example, can be able to help you to have a draft already working, and you can just edit it, and then you can send it through to your customer. And then some of the other ones that are available are sentiment analysis. So you can have some prompts that check for sentiment within a specific text or within a specific input that you're getting either from your user or from your solution, and translation and code generation. But how does this really work? We're going to look at a high-level workflow. At first, you have end users. They consume your content and provide possible input through some of the apps that you built. So it could be a Power App, which is an enterprise app, a Power Automate flow that's running in the background, taking the input from the user, or a Microsoft 365 Copilot, either be it's coming from a Word document or it's coming in from an email. Then you have you as part of this generative AI for beginners course, where you are a maker, where you create custom prompts optimized for a business scenario. And you can utilize some of those prompts within Power Apps, Power Automate, and Copilot Studio to enhance the solutions that you build. And all of these solutions that you're building that are being used by your end users are powered by AI Builder, where you have that prompt creation experience and some of the system guidelines, and even retrieval augmented generation, which is also called RAG. Again, it makes use of AI Builder and Dataverse. And all of this is powered by the GPT 3.5 Turbo hosted by the Azure OpenAI service. It's not managed by you. It's already built in onto AI Builder so that you can then be able to use it to build some of the solutions that you actually have that you're going to ship out to your users. You don't have to worry about managing the GPT 3.5 Turbo model on your own. You just need to worry about building a solution that makes the experience for your users better. Right. With all of this prompt talk that we're talking about, we have to actually think about how to build an effective prompt, because at the end of the day, whenever we are using generative AI, we need to be able to get the most basic or the most wanted solution, or we want the most basic response that we are getting from the generative AI model, for an example. So here comes in prompt engineering, where you have to build an effective prompt to get the best response. So for an example, when you are building an effective prompt, you need to think about a few things. The task, which is an instruction telling the GPT model the task to be performed. Then consider the context as you provide within your prompt that describes the data that will be acted on along with any input variables. The next step into your prompt is the expectation. Convey to GPT the goals and expectations on the response. Then last but not least, the output. Help the generative AI model or help GPT format the output the way you want it so that you don't end up saying that this is not what you're looking for. How do you then be able to use this or take advantage of this within the Power Platform? Like I mentioned earlier on, you have the prompt library and GPT templates. So you can use pre-configured prompts to help you get started with common scenarios like responding to a customer complaint, classifying text, or extracting information from a text, or summarizing text that is coming either from an email or from an application that you actually built using Power Apps. If you want to use some of the pre-configured prompts, you can actually use the pre-configured templates to get you started so that you can be able to integrate these prompts in an end-to-end workflow, and also sometimes into an end-to-end solution that you can be able to use Power Apps to build and then enhance it using an end-to-end workflow. Now, the next step for you is to actually try it out yourself. So go through the lesson, complete the entire lesson 10 to actually build a low-code AI application, and you'll be able to build a Power App by describing you want to build an app to track and manage student assignments. And then there are some other extra steps so that you can be able to build a Power Automate flow by describing what you actually want from it. And also check out the other lessons within this specific Generative AI for Beginners course. We actually give you some of the knowledge on how you can be able to use generative AI with different tools and different levels of expertise.
Hi, my name is Corey Steger-Pace, and I'm part of the AI Cloud Advocacy team here at Microsoft. And I have the honor of delivering to you lesson number 11 called Function Calling and Working with External Applications of our Generative AI for Beginners course. In the introduction of this course and what we'll cover today is really one, explaining what function calling is, and also understanding when we should be using that in our applications. How to use function calling specifically with using the Azure OpenAI service. And lastly, how to integrate a function call into your applications. The learning goals for today: after you complete this lesson, you should have a better understanding of the purpose of function calling, how to actually set up a function call, and then lastly, and most importantly, how to actually design an effective function call so that you have a successful function call within your application. First, we're going to explain a bit of a scenario or what we're actually building here in this course as well as in this specific lesson. In this case, we're going to look at when a user would come in and let's say they want to maybe request that they want to get some courses to learn about different Microsoft products. In the case, the user would make a request directly to a large language model, let's say in this case, GPT 3.5 Turbo. And in the case that we will want the large language model to be able to call a function, in this case, get courses, that would actually make an API call to the Microsoft Learn Catalog API to get courses that would be relevant for the user. And then lastly in the flow, present those options to the user. So that's what we're going to be building towards in today's lesson. But before we even do that, we need to answer the question of why function calling in the first place. Why is it important and why would you want to use it? Well, one of the increasing importance of building applications with large language models is in fact that what many have start with chat applications, whether working directly with the model or making requests directly to the model. We're seeing more and more that applications need to have a precise formatting in terms of responses from the model when they want to actually integrate this into other flows or parts of the application, and not be the application itself. And this is what function calling really addresses. So if we look at this two descriptions here, we have two descriptions of students, Emily Johnson and Michael Lee. We have very similar descriptions in terms of what their GPA is, their skills, and extracurriculars in terms of what they've been doing and where they want to go in their lives, essentially. Now we're going to take two of the same prompts. In this case, we're going to say we want to extract all the information that's important, so their name, their major, the school, the grades, and the clubs that they've been involved in. So these are the same prompts, and we've requested the model to actually send this into a JSON object, because maybe we want to use that format later on, maybe to store that information into a database, or maybe make us some sort of API request with that information. What happens is if we even run these two prompts, what you will see is we might actually get different formatting in the responses that could cause errors in our application unless we check them and maybe add any additional features. So in this case, we have the name, which is about the same, the major, which is computer science, the same, school, which is also in the same format. But then if you notice here at grades, in one, we have a 3.7, and in the other with Michael Lee, we have a 3.8 GPA. They're both strings, but they obviously contain different information that could cause issues in our application later on. So what do we want when we're talking about function calling? It is really to address these concerns in a way so that we can make sure that the formats that we receive are in a good way that we can actually call a function later on in our application and that function runs successfully. So what are the use cases for function calling? Well, like I said earlier, the one is if we want to call any external tools, whether that be tools that our application is using or even what our users are using. And we want to make sure that the format that these tools expect are the ones that we deliver. We also might want to even create API calls or database queries. So in the case of our use case that we're building towards, we will be making an API call. And we want to make sure that we have the right parameters to make that call successful, whether that be the required parameters or even optional ones. And then lastly, if you just want to work with some sort of structured data, working with function calling is another good way to do that, whether we want to use that structured data to display it to the user in a different format that maybe not coming directly from the large language model. So now that we kind of understand the use case, let's actually get started on creating our first function call. So the first thing we'll do is actually create a message. And in this case, it's a very standard format in terms of the messages that we would develop with using a GPT 3.5. And in this case, we have a user that comes in and the content we're sending, and they just want to find a good course for a beginner student to learn Azure. So that's the message that we're initially setting. Then we also need to sort of define the functions. First thing we do is define the name of that function. We give it a general description that is also very helpful for the large language model to identify if that function is relevant. And then lastly is the parameters. In this case, we are going to assign an object and make it have three different properties. One is the role, which also has a description. So this is the role of the learner, the product, and this has a description of what the product's actually being covered here, whether it's Azure, Power BI, or any sort of maybe Microsoft tools that are in the Microsoft Learn catalog. And then lastly is the level. This is the skill level of level of experience of the learner. So this gives a lot of information to the large language model to understand that these are the criteria or the necessary parameters that's needed for this function to operate. And then lastly, we even have a required field that we can set here. So at the very least, a large language model needs to be able to determine that there's a role that's been sent to sent by the user in their chat message in order for this function to operate. Then we're actually going to make the function call. So in this case, we're going to choose the model that we've deployed, all of the messages that we've completed in the cases of the user message or the system message. We're also going to include the functions that we have done. So this is the functions equal functions. And then lastly, we have this function called auto. And auto means that the large language model has the ability to decide whether or not the function is appropriate for this particular instance or this chat message. Then next, we'll actually see what the function call that the model has determined. In this case, if you remember our earlier message, the student had determined that they were a beginner and they were looking to learn Azure. So just kind of looking at what the model has interpreted here is that the role is student. The product that is relevant for this user is Azure. And then lastly, it's a beginner. Now we're actually going to integrate this into our application by importing requests because we want to make an API request, and also the parameters, which is the role, product, and level that this API requires in order to get some information. And then lastly, we're going to take that URL, all those parameters, and append it to the URL to get the results. Then we're going to integrate that into an application by doing a function to call and the available functions, which is the function name that we will have. And then we're going to also load that into JSON so that we will handle the responses within the arguments that we get from the function. Then, most importantly, after we get those responses, we want to make sure that the model has an ability to include that into their messages. So we want to then append that message and give that into the model so that when it goes in to make the output, that this is what the model will receive. So this is kind of ending the flow, is that now the assistant has the role of and the content where they say that find some good courses for beginner students, is presenting the URLs that has been retrieved from the function that was calling the API from Microsoft Learn catalog. And then it also even encourages the user to click on those links if they want to have access to the course. So that was a bit of brief about how function calling works. To get the complete code example, please check out the GitHub repo at the aka.ms/genai beginners that you see here, as well as the full course where we'd explain not only how to use function calling, but also things like AI agents, which are very much relevant in this case. Thank you and good luck.
Hi everyone, this is Bethany Jepchumba, and I'll be taking you through lesson 12 of the Generative AI for Beginners curriculum. In this lesson, we'll be covering designing your user experience for your AI applications. Our focus will be first understanding what exactly user experience is, and then the user in user experience will be diving into what are their needs and how do we now build the different components of UX around the user. And lastly, we'll dive into the specifics of how do you build your user experience for generative AI applications. So let's dive in. What is user experience? User experience is the entire journey a user takes when they're interacting with the application. It's from when a user comes in, gets onboarded to your application and performs a few tasks, and then the offboarding of the user. That entire process is the user experience. How does the user navigate around your product? The main thing I've mentioned is the user. So we should also have in mind who this user is and what exactly their needs are. In our scenario, we'll be creating a fictitious educational chatbot, and our users are two main users. One is the student. As a student, you might come into the application and have it to help you as a tutor to write essays and reports, or come in and have the application generate summaries for you. And as a teacher, you may come into the application and have it generate quizzes for you, or you may have pre-recorded videos and audios that you want to make accessible. So how can the application generate a transcript for you? In the entire UX experience, we have different components that make up how your user interacts with the product. How do you make sure their experience is okay? The first thing is the usability of the product. This means, does the application function as it was intended to function? Does it perform its intended purpose? So for example, if a teacher is coming in to generate quizzes, are the quizzes generated using the application? The other thing is accessibility. This means, the application should be accessible to all regardless of their different abilities and disabilities. And it should also be accessible regardless of the language a person uses. That is, if your application is meant to go global and reach different users. And for us, our application is primarily targeted to all teachers and students, so we should be able to ensure it is accessible for all. The other thing is reliability. We've been able to see that usability is around, does the application perform the function it was intended to perform? Reliability comes in when it consistently performs the different function well without any errors. And then, of course, once your application checks all the boxes, it should also be pleasant. Users should be able to have fun using it. It should be enjoyable and appealing to the different users. That's about creating your application. But what about creating specifically your AI applications? The first thing you should be able to do is ensure you're designing for trust and transparency. So the question a user might ask is, does the response I'm getting correspond to the question that I asked? Users need to be able to trust the application will deliver expected results, and they should do this consistently and accurately, especially an application that is bound to impart knowledge to the next generation. Building trust is critical as it ensures that the user is confident with the application, that it will get the work done and deliver the results. Transparency comes in when you're able to also share with the users, this is the data we collected and this is how we are able to use your data. The key things around trust is ensuring the application gets the work done. It is reliable, it gets the work done over and over again, and the results are able to match what the user needs. There are two risks when it comes to trust, that is overtrust and mistrust. Overtrust is when a user is very overconfident in the AI capabilities and they trust it too much to the extent they do not even verify. They just summarize and then go ahead and give the quiz to the students and stuff like that. That is an issue because generative AI is not 100% perfect all the time. A user should be able to come in and authenticate that what was produced by the AI is actually true. The other thing is mistrust. A user can come from the background of, this is AI, I don't trust what AI does. So those two are very opposite sides of the pole, and we want the user to come back and trust the application. So how do you calibrate trust? There are two main ways you can calibrate trust. The first thing is explainability. Explainability is, how does the application work? Does the user understand what the application works? Does the user understand what they're doing in the application? The first thing is, of course, in the onboarding. When I come into your application, am I able to know this is what the tutor does? So for example, for application, it's welcome on board to your AI tutor. And it doesn't really give you an idea of, okay, this is an AI tutor, but what can it do? What does it do? If you phrase it a little bit different, it tells you get personalized AI tutoring for any subject. It now gives you a clearer idea of what exactly the application does. Then the other thing is ensuring your explanations are succinct and simple, ensuring anyone, regardless of their background, can be able to understand what exactly the application does. So for example, in this example, we have a chatbot saying, hey, Bethany, I use a neural network to process information and generate responses. I might have the question, what exactly is a neural network, right? You might even not know, even if you're in tech, you might not even know what exactly a neural network is. But if you phrase it differently, hey, Bethany, I am a computer program that can answer your questions and help you learn new things, but I am not a real person. That's a different phrasing of the sentence, and it's more clearer regardless of what the background the person is coming from. The other bit around explainability is, how are you able to interact with the users depending on the access they have? For example, if it's an AI tutor and I'm a student coming into the application, I wouldn't expect it to give me responses and give me answers if I ask it a immediately. It should be able to help me answer the questions that I have. For example, in this, student has a mathematical problem and comes in and asks, hey, can you give me the answer to this? And the AI chatbot is like, yeah, this is the answer. That's not right. What you should have your application do is instead tutor the student. So for example, the student comes in, can you give me the answer to this? And the response from the AI is, hey, there's a cool tool that you can use to solve the equation, which is a quadratic formula. And this is how it goes, so on and so forth. It's now acting more a tutor versus acting as an answering machine. The other thing around trust, the second thing is control. Users should be able to have a certain level of control over their AI application. This means you should be able to control how exactly the application responses to your questions. For example, the Copilot extension on Microsoft Edge has a very good tool when it comes to Compose, whereby I can write a question, give me Pani Pan's phone, a generative AI chatbot, and I can be able to use controls to say, yeah, I want it to be funny, I want you to give me ideas of it, and medium length. And even when it gives me a response, because, yeah, what do you call an AI that makes art? A Picasso, which is very interesting. It will also give me room to be able to go in and edit. Okay, can you send me more? Or you can even add in your own suggestions, like those are not funny, can you make them funny or something of that sort. This gives a user control over what responses you're getting from your AI application. Now, we've talked about trust, but then the other bit is you've been able to trust that this application delivers exactly what it should be delivering. But then how do you give feedback when an error occurs? How does the user collaborate with the AI application to ensure the feedback is given? You're also ensuring you're able to improve your user experience. So you should be able to design for collaboration and feedback. The first thing is creating a feedback loop. A feedback loop allows users to suggest different improvements and suggestions they might have for the AI output. For example, you can have a thumbs up and a thumbs down for the feedback loop. So if the response is good, thumbs up. If it's bad, thumbs down. And you can be able to go ahead and even add more features, like if a user says thumbs down, can ask, okay, can you give feedback? Why is it bad? And so on and so forth. These features allow a user to come back and collaborate and give you feedback on the application. The other bit is error handling. Error handling is in case the application does not do as expected, how do you handle errors? So for example, a student comes in and asks, what is the meaning of life? As an AI application that's been trained on just different subjects, you might be cautious to say, this is the meaning of life. So instead, the application should come back and say, hey, sorry, I've only been trained with data on history and math. I cannot be able to respond to the question you asked. This helps handle any errors that come up. So you should be able to figure out the entire scope of your application. How do the students interact with the applications? How do the teachers interact with the application? And how can you be able to handle in case an error happens? Yeah, and of course, as a good teacher, I will also leave you with an assignment. If you've already built an AI application, the objective will be how can you be able to improve the user experience of that application. For example, you can say, how do you make it more pleasant? How do you word your error messages? How does the user explore the application? Do you give room for users to have control in the application? So you can go back, look over the different items I've mentioned, create a checklist and see, does your application check all the boxes? And yeah, that will be your assignment for today. Thank you so much. And in conclusion, designing the user experience of the AI application does not only require it to be functional, accessible, reliable, and pleasant, but you should also be able to think about how are you building trust with the users, and also how do you foster collaboration and feedback to ensure your application is continually improving and the users have a positive user experience. Thank you so much, and goodbye.
Hi, I'm Corey Stegerred Place, part of the AI Cloud Advocacy team here at Microsoft, and I have the absolute pleasure of delivering lesson number 13. Yes, lucky number 13 to you, covering securing your generative AI applications. And if you have the right security strategy, you don't need luck on your side. You have a good plan in place. And that's what we're going to discuss today. So just to do a bit of introduction, this lesson is going to cover security within context of AI systems. What are the common risks and threats that you need to look at when you're building generative AI applications? And just methods and considerations for securing these systems or these applications that you're developing. So the learning goals. So we're going to examine the threats and risks that you have against your AI systems and applications. We're also going to look at methods and practices that you can put in place to secure against those risks. And lastly, how you can actually implement and security testing to prevent any of these unexpected results. And like I said, so you can continue to have users trust and have a working environment for your generative AI application. So let's start with security and generative AI. These two topics and how do they relate to each other? Well, the impact of generative AI cannot be said even more. This diagram is a really good understanding of the market size of generative AI in terms of the applications that are being built. And you can already see that we have more, if we have more generative AI applications, we should have more secure generative AI applications. And taking from this OWASP list, and OWASP is a authority in terms of cybersecurity, they have defined 10 significant threats or security challenges for large language model applications. Well, we won't go through all of these in this lesson. You can check out the link below within the GitHub repo of this course. So you can see all the details of these threats. But there's something that we will be covering, things like prompt injection, over-reliance on a model, as well as training data poisoning, and even model denial of service will be things that we also will cover throughout this course and in particular in this lesson as well. So now that we understand all of the challenges that we have as application developers building with generative AI and large language models, let's look at specifically in details these threats and risks that we have. And lastly, how can we circumvent them or mitigate them through the correct security practices? So we'll look at the first one. It's called prompt injection. And you can kind of think this is using the idea of prompts, so prompt engineering, but not for the intended behaviors of your application. So you can actually, we've seen threats and attacks out there where they've used prompts to either extract sensitive information. So this could be sensitive information that your generative AI application integrates with, or perform unwanted tasks. So throughout this course, we will talk about things like building a meta prompt or a system prompt. And we've seen even attacks on those sorts of methods where users can come in and almost trick the LLM into doing things that it's not necessarily designed to do. This can lead into things like responding with bias or misinformation, or even sending hateful content to our users, largely because all of the security measures or safety measures that we put in place are removed through these prompt injections. And then lastly, even exploiting the vulnerabilities of the AI models themselves. Large language models still is a rather new technology. And if we find vulnerabilities in the models themselves, you can use attackers can use prompts to find out and get unwanted consequences for your users. The next one we're talking about is supply chain vulnerabilities. And this is not supply chain in terms of shipping and things like that, but I like to think of this as kind of like the infrastructure that runs around your whole generative AI applications. So there's a lot of vulnerabilities perhaps in when you're using outdated software. There's many new tools out there in terms of being able to deliver generative AI applications and manage them well. And it's important as application developers to make sure that we're not using anything outdated that could have security vulnerabilities. As well as insecure plugins and toolings, we're finding out more and more that when we hook these generative AI applications into other software systems to get information and data, it actually performs really well in terms of the user experience. But we want to make sure that we're using the right plugins and toolings that does not create any vulnerabilities in that as well. And then lastly, it's the idea of over-reliance. When we over-trust the LLM's responses, and we put those responses in situations where they're prone either to having errors or inaccuracies, because as we have probably discussed it in other lessons as well, large language models, they are prone to either hallucinate or fabricate information at times. And this can lead to unwanted consequences if we just take them as face value and we just lead them to the negative consequences that they present. So now that we've looked at those challenges, like how can we overcome them or build out security tests and systems to protect against these attacks? So with the idea of prompt injection, we really want to mitigate this, whether that's validating the input of the user, so we're making sure that this isn't any disruptive prompts, or content filtering, where we're making sure that the content that is being sent to the users goes through a filter, or even sanitizing response and request in the cases so that we're making sure that this information is what we are expecting to send to the model. And then largely it's about monitoring, making sure that we're logging users' inputs as well as the responses. And if we see any typical attacks, even adding those users or that information to certain watch lists so we can make sure in the future to mitigate those harms. Next is supply chain vulnerabilities. So we always want to ensure that we're using the latest secure version. And I don't just say latest version, because sometimes the latest version, unfortunately, is not always the most secure. But using the latest secure version or latest one deployed, we'll also want to verify the plugins that we're using, or even build our own plugins if necessary. And then verifying the model for correctness and completeness is an important step. And then lastly, through the testing of what we call adversarial testing, which is through AI red teaming, where we're actually challenging and creating scenarios where we might see vulnerabilities in our applications, and then finding out where we can improve upon. And on the over-reliance standpoint, again, this is all about over-trusting the output of the model. The first step is user education. Giving them the understandings of the limitations of the model or where errors could occur is very important. Also, verifying the output and monitoring them with various monitoring tools that are available. And then lastly, testing and evaluation, presenting not only a relevant prompts that you think of, but also a very diverse set of prompts towards the use case that you're building, so you can see the types of outputs and responses that you get from the model is very important in terms of how the user experience is driven after you've launched this into production. So that wraps up this lesson in terms of building security applications or securing your generative AI applications. You can get more information here in the full course at aka.ms/GenAI beginners, and keep building secure. Thank you.
Hey folks, welcome back to Generative AI for Beginners. I am Pablo Lopez, Global Cloud Advocate in .NET and Artificial Intelligence here at Microsoft. You folks saw me twice already, right? So it's a pleasure to teach you folks again about Generative AI, and this time let's pick a more complex topic than the last times. First, so now I believe you folks know a lot about Generative AI. You folks know how to generate text. You folks know how to use images. You folks how to know a little bit of fine tuning, prompt design. You know a lot, and even use AI functions. Yeah. So now that we are coming to the end part of the series, I want to tell you a little bit about LLM ops, right? Because here's the thing. We talk about a lot of theoreticals, right? We talked about on how can you use this parts of all of your generative AI systems into new systems. But you know that's not always the case. You need to develop systems. You need to make them scale. You need to take care of a lot of stuff. So now you know how to use, operations, how real operations work with LLMs and language systems. What we cover today? We're going to cover LLM ops, LLM lifecycle, Azure AI tooling, and evaluation. Then what we're going to learn? We're going to understand the paradigm shift that happened between MLOps and LLMOps, the LLM lifecycle, tooling, metrification, and evaluation. Let's start very simple. Let's start before LLMs, right? Before LLMs became more mainstream. So we had a lot of MLOps, right? Which is machine learning operations. So we had to worry a lot of machine learning operations to maintain our models in great shape. So we had a lot of, very technical people dealing with constantly. You have your data scientists. You have to have people that knew a lot of the machine learning itself to understand how these operations are going. So we had to have a lot of technical people, as if that was not that accessible. And if you weren't a very technical person, you have a lot of difficulties to understand how to maintain a tool chain complete for machine learning operations. But then we had LLMs. And the cool part about LLM is that they simplified a lot of tasks that were really hard for machine learning operations, especially now with prompt engineering, a little bit of, the ROG pattern. So we have a bunch of new things that now you can learn that you can apply to your LLM ops. So if you don't know a little bit about retrieval augmented generation, you're going to see on the next lessons. So let's talk about this paradigm shift. So let's start with the traditional ML ops. So we have a lot of ML engineers, data scientists, and what they share was about the model, the data, the environment, and we had only one metric, accuracy. And a lot of those machine learning models you have to build from scratch. Now we have LLM ops. And the good part about LLM ops is that now it's not just reserved for those ML engineers and data scientists. We have as well our app developers. So now everyone can join and trying to do a better AI solution for everyone. And as assets change, of course, you still have model, data, etc. But now it's easier to manipulate. So you have your LLMs, your agents, your plugins, your prompts, your chains, and your APIs. Remember when we said a lot about Azure AI? So that's the thing why I want to show you, is to demonstrate how much now we can change more easily to have access to those AI solutions into your applications. And not only that, for metrics, now we have a lot more metrics. And you may ask why. It's because of AI ethics. Now with the power of those big language models, we need to worry a bunch more about how it's being used. So we have water quality, which is the same as accuracy, right? But you have to worry a little bit about the similarity depending on your prompt. We have our biases, right? So we need to take care of the harm that it can take. So the bias and toxicity of the responses. It has to be honest. It has to be some ground level to get correct information. So I need the groundness. And I need to take care of the cost and the latency. The cost being the total token per request, and the latency being the response time and response seconds, RPS. So here I have as well on the base of the ML models. You can see it's pre-built. It's fine-tuned to serve as API. It's a model as a service. That's why it's in AAS here. So you can see here that now we're changing a lot of paradigms. Now even app developers can participate into a AI-enabled platform. And it's not only this, right? Because right now, the life cycle is changing a lot. Because you must remember that before this, now we need to understand, if you are an app developer, how to make an LLM cycle in the real world. So what is going on here? We have here the classics, the base of all our AI-driven needs, which is the business need. Remember, all AI solutions need a business reason to exist. So we always need to get a business need to apply your AI solution. So after this, we're going to apply this into the ideating and exploring. So we need to do hypothesis, try to find new models and LLMs or even SLMs, depending on the scope of your solution. Then you're going to try prompt engineering our way to get good accuracy. After this, we need to build and augment our solutions. So then we're going to do now a more advanced prompt engineering or fine-tuning or even both. You can gonna use evaluation to see if our solutions are scaling, giving right answers, and understanding how it's performing under the tests. to handle exceptions, and have especially retrieval augmented generation, which is a pattern that is trying to get answers from documents that you insert. If you have any doubts about it, check our Generative AI playlist that you're going to have an episode on retrieval augmented generation. So after this, imagine that all steps go through with building our solution. That's great. Now I need to operationalize. So basically now you're going to apply the basics of all operations. So I need to take care of the quota and cost manager of your AI solutions and LLMs. You take care of the monitoring, the safe rollout, the content filtering, and the deployment of this app or UI. So everything will be need to be operationalized to take care of everything that you need for your solution. So you see that we have 3 steps, and these steps can go forwards and backwards. Basically, you're gonna advance projects, prepare apps for development, but if you want a new version, you can revert to new ideations and explorations, or even get back from feedback from the operations and building again into your new solution. Here you can see a more complex infographic of everything here we have. So we have here to identify the business user case, to connect the data, build your prompt flow. If you have doubts what is prompt flow, I'm gonna show very soon. Develop prompt flow based on the prompt state compatibility to see if it's doing correct and see if the data that you have can work perfectly with the flows that you have. Then you're gonna do testing. It's a lot of tests in the second part. So you have to run tests, evaluate if the prompt flow goes, and you can modify or not. After this, if everything goes well, you can always go forward. If not, you can go backwards, as always. You can go and deploy an endpoint. If not, try to modify a flow to yield better results. So after it got great results, you can always deploy your endpoint, add monitoring, and integrate it to your application. But I want some more examples. Do you, Microsoft, have some examples on having a whole flow? For sure. Let's take a look on it. So here we have a perfect sample. We already have Contelso Chat. Contelso Chat has a lot of the features that you're looking for. So here you have an LLM, which is easy deployed with Azure SCLI and has a lot of LLMs use cases. So with here you have a lot of the learn objectives. So if you want to understand RAG, you have to take a look here to build, run, evaluate, and deploy a RAG-based LLM app. So now we need to understand how you're going to evaluate, right? Because I talk a lot about testing, and testing with LLMs is usually a harder task that you usually know. So let's take a look on how we evaluate internally. So on Contelso Chat, we have this folder called eval. Take a look here. Then you can have a lot of IPython notebooks to see how it works. So here it is a non-Python notebook talking about how to evaluate groundness. So here you have a question, a customer ID, and an output. The customer ID here, it refers to a specific client. So then you're gonna use PF client, which is from PromptFlow. PromptFlow is our tool application to make flows easier. What is a flow, you may ask? A flow and prompt flow means that we know which process it goes from question to answer in which points of the code it touches. So what is retrieving, what is getting from the database, which points of the code it is executing to get the correct answer. So here we have prompt flow here applying into code. So here goes to the flow and then goes to the inputs. Then I get an output, and the good part is that prompt flow has a test. So you can get the question, the context, and the answer, and then you get to 0 to 5 into the grading. 5 being 5 the best and 0 the worst. Then not only it can try to evaluate on just groundness, it can evaluate it on a lot of things. It can evaluate the question between all those points that I touch. It is harmful, it is grounded, it is correct. Remember, not always being grounded to be correct, and if the answer makes sense, because yes, it can answer correctly. Imagine that I say, the guarantee is 60 days. However, imagine that 60 days is not guaranteed. Okay, it got the information correctly, but then wrote it wrong. So sometimes you need to take care on how it answers. Not only you need to pass the information, but it has to complement it. And you need to take care if it's getting correct. And you can do a batch run to do a bunch of questions to try to understand if everything is run correctly. So these are some of the parts we can do, but we have a lot more. Please take a look on Contoso Chat on Azure Samples. And if you want more versions, we have more versions here on GitHub. So thank you so much for joining us in this new episode of Generative AI for Beginners. If you want to know more, you can always access our resources on Microsoft Learn. And not only that, we have talks just we had like this on Microsoft Ignite and Microsoft Build. Take a look on how we implement RAG solutions into this operations new world. Thank you so much, and I hope to see you soon.
Hi everyone, welcome to the Generative AI for Beginners curriculum. I am Bethany Jepchumba, and I'll be taking you through lesson 15, that is retrieval, augmented generation, and vector databases. Let's get started. In this lesson, we'll cover why exactly you need RAG, why you even need to care about it, talk about the components of RAG, and we'll show you how you can be able to build a full RAG application before we conclude the session. In our scenario, we'll be using Azure OpenAI as our LLM. Then we'll be using data from the AI for Beginners curriculum, the lesson around neural networks, and we'll have Azure AI Search and Azure Cosmos DB for our database and search index. Currently, our LLMs have a couple of limitations. For example, the limitation around knowledge around current events. If you go in and ask, is Queen Elizabeth II alive? The AI model will tell you, as per my last update on October 2021, yes, she was, but I do not have real-time data. The other thing is around your own personal data. So it was trained using publicly available data. So if I want to ask what is the price of cakes from a specific store, it will tell me, I'm sorry, as an AI model, I cannot tell you the real-time prices of specific stores. The other limitation is around the context provided, as well as data. The responses generated might not be rooted in fact. With these limitations in mind, we have the solution of using retrieval augmented generation. This is whereby you add supporting information to a prompt to give it more context and knowledge, so that when you go to the LLM, it can give you responses based on the data provided. How it works is a RAG application acts whereby a user asks a question and the application queries data from a knowledge base, adding the data as well as your query to the prompts that you query to the model. Then once you get the results from the model, it's both a combination of your data as well as the user prompt a user asked. So regardless whether a person is asking questions around prices of items in your store or prices of personal data, for example, if you have your own data on Microsoft Word and you want responses, retrieval augmented generation can come in and help you augment your responses with personal data and generate more, better, and succinct responses. The components of a RAG include one, a knowledge base whereby the data is stored and can be able to retrieve the data, a user query once a user asks a question, and then the retrieval system where now you build an entire system that can be able to go in, retrieve relevant information, augment it to the prompt provided, and generate a response based on the data retrieved. In this scenario, you have heard about the knowledge base. But then how do you store your knowledge base? You use a vector database. A vector database is unique in that it can be able to store embedded vectors, not just storing documents as they are, but it also has numerical representations of your document to be able to now interact with large language models. Once you've been able to have all these things in place, we can go ahead and create our RAG application. The first thing, of course, is ensuring we have our knowledge base ready so we can create our Azure Cosmos DB to be able to store our data. Once you have your database, the next thing is you have your data. Your data might be in long paragraphs. For example, if you have a book and you might want to split it into short passages to be able to have the LLM easily retrieve the data, as well as reducing the cost in terms of the tokens passed through your LLMs. So the next thing you do once you have your data is to break it down to chunks for easy retrieval. Next thing is now embeddings. Embeddings are encoded data format that you can be able to use as input to your data, to your application. So the next thing, once you have your chunks, is to convert the chunks to embeddings. Converting the chunks to embeddings enables you to, of course, also have a higher retrieval speed, as well as being able to easily find the similarities between different chunks. In our scenario, we'll be using the text embedding ADA002, the second model, to be able to embed our data. You can use other vector embeddings such as Word2Vec to be able to do your embeddings. So you can go read on around what are the different embedding tools I can be able to use and how do I ensure it's the right one for my application. Once you have your embeddings, you now want to be able to get which are similar to the prompt provided. As we said, what you're doing is augmenting your prompt with your data. So you want to find the data that is most related to the text that you provided. So once you have your text, you'll go back to your data and be able to have similarity assigned to your data, to your vectors, ensuring that you can be able to find words that are closely related in a document. We can do this, of course, by creating also a search index. Once you've been able to being able to figure out how similar your words are, you can go ahead and create a search index to be able to now go in and retrieve chunks that are similar. And now you can be able to go in and embed your prompt with related chunks. But then the question might be, okay, you have probably your data spread across different chunks. Probably you might have one that's very closely related, another that's not closely related. So you will want to come in again and ensure you are able to rank them in order of relevance to be able to now get such results that are most relevant to be able to be chunked together, to be able to be retrieved together with your prompt. This ensures that the most reliable data, the data that is most closely related to your prompt is now ranked on top. You can also do this as well with your code by creating a re-ranker to be able to now rank the chunks. Okay, these are the chunks closer to the question, and so on and so forth. Once you've been able to go in and create your re-ranker, you've been able to create a search index, you want to bring everything together into an application and get a response. So, for example, in our code, the first thing is the user input. So a user might ask, based on the data, what is a perceptron? And then we have our chatbot created. You query first the embeddings that have been created. You create an embedding of first what is a perceptron. Once you've been able to create your embeddings, you go in and find which in your database, which data is closely related to the embedding of the question. Once that's done, you can be able to append that to the user input. And now the question that's going into the LLM is both your question, the users, and as well as the data that you've been able to retrieve. This is just an API call to be able to now come in, use OpenAI to be able to generate responses based on your question. And from the response, you can see it gives you a response of perceptron is a type of artificial intelligence, neural network model, and so on and so forth. You can be able to also add other features to your application, such as, for example, can you also retrieve the document or the exact chunk whereby I can be able to find the question that has been asked, as well as the content that we've been able to add on top to now get a clear picture of what exactly
what point of your data exactly did you get the response from. And that's it. You've been able to build your RAG application. But then the question might be, okay, you built it, but how do you ensure that your application is actually working in the same way that you intend to work? We have 3 different evaluation metrics that you should look into. One is groundedness, to be able to evaluate, did the response come from the documents you supplied, or was it just random responses? So you should be able to go back in and check what responses did you get and how do they match with the data you provided. The other thing is relevance, in terms of we were able to rank our data in terms of the most relevant based on the similarity of the vectors. But then you also want to ensure that that was the most relevant, that the most relevant data which was used. Then the last thing is coherence. Coherence is around how fluent or how close to natural language did the text retrieve sound like. And that's it. Of course, I will leave you as an assignment, and I want you to continue learning about RAG, continue building on top of what you've learned. So I'll leave you with 2 tasks. First of all, the first task is, can you be able to build a front end for the application and be able to have users actually interact with your RAG application? And the next thing is, are you able to utilize a framework to recreate your application, make it more simpler, or even use other tools like, as you've seen, I've been able to create the search index from scratch. I was able to create a search index, but then we have other applications such as Azure AI Search that can be able to do all this without you being able to create from scratch. So you can also explore all those other options. And with that, thank you so much for joining in and have a good day. Bye.
Hi, I'm Corey Segarad-Pace, and I'm part of the AI Cloud Advocacy team here at Microsoft. And I have the pleasure of presenting to you lesson number 16 of our Generative AI for Beginners course, covering working with open source models. In this lesson, we're going to cover what exactly are open source models, some of the benefits of why you would want to use open source models, and also understanding where we can find the different open source models that are available to build our applications. We also have some learning goals here. We want to understand the difference between these open source models when helping us determine which ones to use, how to actually use these in an application, and where to find more detail about these open source models that are available. So what are exactly open source models? The standard definition that we've sort of taken from open source software would put this category of that all this information, when we were talking about large language models, whether it's the training data being publicly available, the full model weights that were used for training, the evaluation code that was also used to evaluate the training, as well as fine-tuning the model, the training metrics that we determined during that process. And then last but most importantly is also an open source license in terms of being able to use this as a developer freely without any sort of restrictions. This is the sort of criteria that an open source software would have if you translate that over to open source models. If we look at the available models that are out there now, there's actually only a few models that sort of fit all of these criteria perfectly. One series of models that is worth looking at is the OLMO models from Allen AI. OLMO or OLMO is short for actually open language models. And these models are, like I mentioned, a series of models. The most latest one is 7 billion parameter open LLM, which is comparable to, or even outperforms in some metrics, with Llama 2, which is a 13 billion parameter model. You would also see available the dataset that was used to train on, which is the Domo dataset, a dataset that has 3 trillion tokens, and it contains a lot of information in terms of both code, content, whether that be web content, and books, whether that be publicly available books or even publications. As well, if you are interested, you can see the evaluation and fine-tuning code that was involved in this process. Well, as I mentioned, this is a prime example of where a model kind of fits all that criteria for probably calling open source models. Where the community has sort of focused on lately is this world of open models, where they might fit some of the criteria, but maybe not all of the criteria that if we were to translate directly into what open source software is. And this is where you'll primarily see a lot of either the model hosting or model providers out there, whether it's a Mistral, Cohere, Meta, or even a Hugging Face, which actually hosts these models when we're talking about working with open models that are there. So throughout the rest of this course, we're going to call this open models, but this is interchangeable in terms of open source models if that's what you prefer. So what are actually the benefits of using these open models? Well, first, they're highly customizable. Like I mentioned, some of these models have open weights, which that leads developers to be able to either fine-tune or alter their behavior, which is very important when we're talking about creating these models for a specialized task, whether that's speaking different languages, speaking different programming languages, or maybe performing different rule sets in terms of the way that these models operate. And they're only being available because of their open sourceness. Also, on the cost perspective, essentially these models on a whole are averagely is more or cheaper than the proprietary models that are typically controlled by one organization, whether that's be a cost per token when utilizing these models, which is also contribute to both the model size, which has some flexibility in terms of being able to host it, whether that's hosting it in the cloud or even working it locally on your machine. And like I mentioned earlier, it's the flexibility that provides these open source models with a lot of benefits. We are seeing a lot now where applications are determining and working with a multi-model architecture, meaning that maybe a certain model performs well on a specific task or is even specialized on that specific task. And maybe that incorporates with either multiple open source models or an open source model and let's say a proprietary model. And working with these open source models are essential because, as mentioned, because of the cost and performance that they deliver, it adds a lot of benefits in terms of building applications when we're talking about scaling later on. Also, flexibility is really getting the understanding of the task and their specialization, how they actually perform with your task, whether it's summarization, text generation, code generation, is another really important part of working with these open source models. And once you understand that, you can get great benefits of working with these models for sure. And then lastly, it's community. We're going to talk about a bit more about Hugging Face later on, but there's things like the Hugging Face Hub, where you actually get a lot of different diversity in terms of fine-tuned models. Like as mentioned, you can get a fine-tuned model that speaks even a language that specific languages are specialized in that. And it's really this concept or this idea of innovation in numbers. If everyone's sort of contributing, we have a lot more freedom in terms of innovating, as well as the abilities to create new tasks, new specializations that might be overlooked by working with just proprietary models. So exploring different open models is another very important question to answer because, as mentioned, there's many of them out there. One way you can work with this is using the Azure AI Studio. We actually have a model catalog built into this that, as I say here, currently has 1,600 plus models. I put the plus here because models are continuing to be added almost every week. But the collection also includes the Microsoft research models that are out there, specifically the ones around even small language models, where we talk about cost and performance as another really good key. The Hugging Face models that are out there available, Mistral models, which we'll talk a little bit more in details, Cohere and Meta are also models that are available or parts of collections in this model catalog of the Azure AI Studio. So do check it out, and you'll definitely find the models that are most appropriate for your application there. Speaking of those models that are available, we're going to look at a little bit more in depth about a few that are available here. First one we'll look at is Llama 3. And Llama 3 comes in essentially three different model sizes or model flavors, if you will. First is the Llama 3 8B, so 8 billion parameters. We also have available the Llama 3 70B, which is 70 billion parameters, as well as the Instruct that uses it for chat completions. You will see this if you want to compare this to a proprietary model. It's comparable to a GPT-4 and also performs GPT-4 on some tasks. So again, as an application builder, it's really important to understand those tasks that it does outperform. And then you can implement that within your application to get the best benefits and performance when using this model. And one of the strong suits is that Llama 3 also operates or delivers fast image generation. So if you were working with an application that requires that, Llama 3 is worth working with or experimenting with within your application as well. The next provider that we have is Mistral. Mistral has 3 currently open source models that are available in the model catalog, which is a 7B, an 8x7B, and an NX, the most recent one, 8x22B. What's unique about the 8x22B is that this has actually native function calling built in, which is the first Mistral model that has that available on an open source license. And that allows you to get essentially allow the model to call functions with your application based on the user's inputs, and actually then get those responses back and send that to the user. So this designs a very much a user-friendly experience outside of just doing a chat application and expecting the response from the model. What makes this unique and why the cost for this is could be less than working with proprietary models, it's its unique architecture, which is this mixture of expert architecture that allows essentially two expert neural networks to be chosen at a time and perform the given task at an inference point, and allows that model to run in a more lightweight fashion compared to larger models that are available. It also has things like JSON and safe mode, which gives developers a bit more control on the responses that the model outputs. And then lastly, we look at the Hugging Face models. So in the world of Hugging Face, there's currently 600,000 models available. We won't talk about all of them here, obviously. But one of the things I like to think about when working with Hugging Face is this idea of maybe working with AI applications, sort of like Legos. Well, there's so many models that are out there that do either general tasks in their multimodal models, but also very excelling at a very specific task. And if you make sure that you use these models in your application for those specific tasks, that you'll get a lot better performance and a cost weight analysis there when you're using, let's say, a model that's really good at translating a specific language, and then another model that's also really good at transcribing that specific language, rather than using or relying on one model to do that as well. And like I mentioned earlier, there's really a strong community around Hugging Face that gives you a lot of information about working with these models, whether it's the discussion, the model cards that are available that gives you understanding of what these models are specialized at, how they perform, and as mentioned, a really strong community around fine-tuning as well from a performance perspective. So if you're looking for a model to be fine-tuned, you most likely find it in Hugging Face being available. So that covers a brief in working with open source models or open models. Check out the full information about this lesson on the GitHub repo, which is aka.ms/genai-beginners, as well as other lessons covering topics including like the full application lifecycle when working with generative AI applications, which is an important part when we're talking about working with open source models as they fit within that application lifecycle. Thank you and good luck. Hi, I'm Corey Steger-Pace, a cloud advocate here at Microsoft, part of our AI cloud advocacy team. And I have the pleasure of delivering to you lesson number 17 of our Generative AI for Beginners course covering AI agents. In this lesson, we're going to cover a few things. First, we're going to answer the question of what exactly are AI agents? What are AI agent frameworks? How do they sort of work? And what are the differences between them? And when should you actually use an AI agent when building generative AI applications? The learning goals of this lesson is going to be explaining how AI agents work, understanding the difference between some of the popular frameworks out there, and then how to design properly working with AI agents. So what exactly are AI agents? This is a very open definition of what AI agents are. It means a lot to different people when they're sort of building with applications. But to standardize this or to keep it really general, we're going to understand that for an AI agent to be defined, you need to have 1, a large language model, 2, some sort of state, and then lastly, tools. So with a large language model, essentially what I like to say is it's kind of this choose your own adventure game. With a large language model is trying to reason or decide on which tools to actually use when you're working or interacting with users. And then we have this idea of state, which is really the sort of the context of the conversation or interaction with users, or even another large language model in terms of the past, what it's been received, and the present of what it's sort of planning to do next. Then it's also maintaining those particular results so that the user is getting the task they want to have completed or that information that they need. And then when we talk about tools, that could be any sort of external system, whether it's a database, an API, even another large language model, or maybe even just some code, whether that's Python function, things like that, that are being utilized by the large language model or being interpreted by responses that the large language model should, in the next process, execute the function. So now that we have a very general definition, let's actually look at how different AI agent frameworks sort of implement this idea of large language model, state, and tools. So in the case of LangChain, who also has available features, we have the large language model, which can be defined very simply as whatever sort of model that's available or what we're going to be using. In this case, we're going to use GPT 3.5 Turbo. Then from a state management perspective, we can define a specific agent, whether that's, we have this agent, we're going to say we're going to use this to create OpenAI functions. And what's nice is also we want to define the large language model, which again is going to be GPT 3.5 Turbo, the tools. And in the case of LangChain, there's actually a whole catalog of tools that are available. In this case, we're going to use something called Tavly, which is basically a search-based tool, and then the prompt. So what the actual user is being requested there. So in the case of the large language model, again, it's GPT 3.5. We have this defined. We're going to manage the state by, what is actually going to be being discussed or between the agent and the user. And then lastly, again, the tools. How do we determine which tools to use and what information that they actually need in terms of whether it's a search, whether it's API request or a database. And that's a very standard way that LangChain uses agents. If we were to get more advanced in terms of complexity, we also have other agent frameworks that are available, things like AutoGen, which in fact we can use where there's actually, we can even give, in this case, multiple large language models, or even large language models that have a very distinct or different system message. And the system message is basically a way to sort of define the rules of where the large language model will operate. So in the case here, maybe we want to indicate or simulate a discussion between a technical team. And we give one agent or the large language model the name of coder and a configuration where the system message is acting as a developer within the team. And in another case, we're going to have a large language model operate as a product manager. And we also give that a clear and distinct system message that may be different than the coder. And then we want to manage the state here. And we actually do this with an AutoGen, what we call a user proxy, which essentially is one that's going to be interacting with the user, taking in sort of the request, as also operating and making sure that whatever the user wants, whether it's executing a function, that it executes the correct function. And then lastly, in the case of AutoGen, we can define tools. And in this case, we're going to use these tools to be functions within our code. So we have one, in this case, doing exchange rate and looking at the symbol and then doing the proper exchange rate there. So when a user, in this case, when it says how much is a certain amount in USD, in euros, the large language model then responds back by executing that particular function and getting that result out. And the last framework that we'll look at is TaskWeaver. In this case, TaskWeaver is very much focused on being a code-first agent framework. And what they mean by that is, first we can define and configure the large language model that's available, which is the model. In this case, again, we're going to use GPT 3.5 Turbo. Then the state is essentially managed between what we call a planner, where we have, in this case, the TaskWeaver, the agent's going to take in the request. So in the case, we're going to generate 10 random numbers. And then the code interpreter will initiate a plan how to actually execute that. And in this case, we're actually going to say that it's going to execute and handle the request. That's the first step, and then report back the result. Pretty standard in the way that this function or this request would happen, because generating random numbers is pretty straightforward in terms of code. But then we also have other tools that are available. We actually call them in the world of TaskWeaver plugins. In this case, this plugin is an anomaly detection plugin. In the case that we have a function that's going to determine within the data if there's any anomalies that are available or anomalies in the data, and report that back to the user. And again, this is a code first framework. It's going to execute within their sort of code interpreter how that function would operate. And the user has the ability to either control or that execution or not, depending on your config that you have set up. So this was a very brief look at the different AI agent frameworks out there and some of the use cases that you might want to use there. The complete lesson, and for more information, do check out the GitHub repo at aka.ms/genai-beginners, as well as other lessons, including one covering function calling, which is also a very important part when we're talking about working with AI agents, as they work hand in hand to execute user tasks that maybe users want to complete in our applications. Thanks and good luck.
Hi, my name is Nithya Narasimhan. I'm a senior AI advocate on the developer relations team at Microsoft, and I'm excited to be here today to talk to you about fine-tuning for LLM, Chapter 18 in Generative AI for Beginners. So what are we going to cover today? Today, we're going to help you answer 4 questions. First, what is fine-tuning? Second, why is it useful? Third, when should you use it? And fourth, and most important of all, how do you get started fine-tuning your large language models? So let's dive in. So first, a really quick introduction. We want to give you a concept of what fine-tuning is, why it matters, and when you should be using it. Why is it useful? And if you've been following this course, you've probably heard of terms like prompt engineering and retrieval augmented generation. So how is fine-tuning going to help us, given we have all those other solutions as well? So let's start with a very simple definition. What is fine-tuning? Fine-tuning is a common practice in machine learning where we retrain an existing model with new data to improve its performance on a given task. So in some sense, this is more of an advanced technique because in order for you to fine-tune the model itself, you need to have good data. You need to understand how to evaluate that fine-tuned model to kind of give you the accuracy and performance you want. And if you don't do it right, you might actually hurt yourself by degrading the performance from where you started. So when we think about fine-tuning, we're actually thinking of the difference between a fine-tuned model and a foundation model. So when you use large language models today, you're actually using a foundation model that's trained on a massive amount of data and is really good at general purpose tasks. When we think about fine-tuned model, we're looking at how good is this model for my specific task. So why should I fine-tune? We've already heard about techniques like prompt engineering that can make the responses of a foundation model better for my particular application. I might also want to kind of use a technique or a design pattern like retrieval augmented generation to ground the responses in my data. All of these techniques help me improve the response quality of a foundational large language model. So why fine-tune? Fine-tuning is appropriate if your desired response quality can't be achieved with those solutions. And there might be many reasons for this. One example is tokenization costs. If you remember from prompt engineering, most of these models have a max token size window. And when you want to train them, you actually have to add in examples. Think of like few-shot learning, where you're putting those examples in with the prompt. So now you have limitations based on the token size. You have additional tokenization costs. So there are limitations with prompt engineering. Another reason might be the skilling, like the capabilities of the underlying model may not give you what you need for your particular application, and you want to upskill it. The third, and again, this comes back to cost, is that it might be easier and cheaper for you to take a lower generation model and upskill it or retrain it for your needs than to pay the cost for a higher price model. So does that mean you should always fine-tune? Not so fast. The most important question to ask yourself is when you should fine-tune. And you should only fine-tune if the benefits of the fine-tuning are going to outweigh the costs or weaknesses of the approach. So here are some questions you should start by asking yourself. Do you have a good use case for fine-tuning? In other words, does your application really require you to bring in data and retrain the model? Or can you get away with decent performance with existing strategies? It could be because you have an edge case that's not covered, or you want to upskill, as we mentioned before. It could also be because perhaps the default models don't give you the same kind of like control over the formatting or the personas that you want to adopt. Next, you want to ask yourself, have you tried other options? Have you looked at the other options and evaluated them? Do they give you enough performance? Are you doing this for a particular measurable attribute? Third, did you factor in the other costs? So when we think about it, we're always comparing to tokenization. You're like, oh, I'm going to save on token costs, or I'm going to kind of have less that I have to ship with every prompt. But it turns out that when you want to fine tune, you have to pay for the compute for fine tuning. You have to pay for the data gathering and cleanup. And then you've got to maintain that model, because once you fine tuned it, that model is now yours. So if the foundation model evolves or your scenario evolves, you've got to retune it. And finally, did you confirm the benefits? So if we've come this far and you've said, yes, I think I want to fine tune, the next question really is, how do we fine tune, right? So fine tuning a model is not a trivial process. So you want to first ask questions like, is the foundation model actually fine tunable? If you go look at, and let's talk about OpenAI models, for instance. If you go look at OpenAI models, not every OpenAI model is fine tunable by default. You need to look at it to figure out, hey, which version or generation of the model can I fine tune? And you may also find that providers only allow you to fine tune these or run fine tuning jobs in certain regions. Next, do you have the right data? In order for you to retrain this model, you better have the data that represents the skill or the use case or the feature that you want to actually build in to this fine-tuned model. Next, do you have a compute environment to run the job? So when it comes to OpenAI, in this particular tutorial, I'm going to show you the OpenAI compute environment, but of course, you can now bring it to Azure OpenAI and use the Azure OpenAI environment for computing. And last but not least, once you fine-tune the model, remember now you've got to host it and make sure that's available to your clients for inference. So you have a hosting environment. Again, this is where trying this out and then using Azure OpenAI makes it fairly seamless. So what does that fine-tuning process look like? Think of it as 4 steps. First, you're going to prepare the data that you need to fine-tune your model. Then you're going to train the model. Then you're going to evaluate whether that model is providing you the results you want. And once you've done that, you're finally going to deploy it. So when you look at the data preparation, some of the things you want to think about is the size of the training data. How many examples should you have? So in the next segment, I'm just going to show you a really quick demo that you can use to kind of figure out the process on your own. And for that, it's a toy example. So we're only going to have about 10 examples. But in a real world scenario, you're going to need about 50 to 100 examples or data records to fine tune your model. You might even need more. Next, you want to look at things like data representation. Is the data you've collected fair? Are you covering all the possible cases so that you're not kind of biasing decisions towards one demographic over another? Is the format of the data appropriate? For example, we need JSON-L. Have you actually got that rendered in a way that can be validated and used for training? And then, of course, requirements coverage. Does your data provide all the examples you need to cover the use case for which you're training it in the first place? Evaluate is where you upload the data for training, create the fine-tuning job, and then run that job for test, and then test that fine-tuned model for the quality of the responses that it provides. And let's say you look at it and say, for the use cases that I asked for, this is doing well. And OpenAI actually is a dashboard that allows you to look at those metrics. The last step is for you to then deploy that model so you can hit it either through code or from something like the playground in OpenAI, in other words, a no-code model, to actually test it out in the real world. So let's see what that looks like. To do this, I have a toy example. Remember, this is only to show you the process. This is not really a realistic example, but it'll help us walk through the code and understand the steps that you need to take. So in this case, what I'm saying is, hey, I want to build a factual chatbot that answers questions about the periodic table elements using limericks. In order for me to do that today, what I need to do is I need to provide the system context. And I want that answer in a particular format, as you've seen. So I need to provide few short examples, and that's all it costs for me. So I want to explore, how do I fine tune the model? And I want to use GPT-3.5 Turbo. So to start with, let's actually go and see if we can take a look at what this looks like. So over here, I have a system prompt that says URL, a factual chatbot that answers questions about elements in the periodic table with a limerick. And I'm just using GPT-3.5 Turbo. And I'm just going to say, hey, tell me about carbon, right? Or copper, or anything, any element you like. And you'll notice that this actually will give me what I want because I've got a system prompt. It's not in the format that I want. It doesn't actually have the specific kind of flow that I'm looking for, but it does the job, right? So now I want to fine tune this. How do I go about it? Before I kind of walk through the slides, I'm going to point you to our repo. And if you go look in the repo, and this should be in there today, there is actually, under Generative AI Beginners, if you go into chapter 18 and you look at the assignment, you will find there's a data file and a notebook. And if you open up that notebook, you will actually see what you're seeing here. The easiest way for you to walk through the notebook is to put this into outline mode, and then you can kind of just step through the different parts. So we talked about what the 4 steps of fine-tuning are. Step 1, you're going to prepare the data and upload it. So when you prepare the data set, remember we want a chatbot that knows how to speak in limericks. Here is what a single record looks like. You can see that I've given the system content. Here is the persona. And I've given it examples. Here's the content. Here's a user prompt. Tell me about gallium. Here is what the example should look like. See the hyphenation. See the kinds of content I have for each step of the limerick. Now, in this, you're only seeing 2 examples. If you actually look at the data, you will find that we have about 10 examples in there. And let me see if I can just quickly bring that up for you. The most important thing you have to pay attention to is that every record should be in a single line. So don't look for default JSON formatting. Make sure it's in this format where each record is a single line. And if you don't, then your job will fail with validation errors. Next, once you've got your data prepared, and I have 10 records for this, next, I want to upload my data set. If you've been looking at our notebooks, just have an OpenAI key. I have currently an OpenAI-based notebook, and I will have an Azure OpenAI one later. But over here, you would need to have an OpenAI key and have that set up, and we do have guidelines for how you do that. But once you do that, the code is really simple. You create a job by opening up this JSON file, give the purpose as fine-tuning, and submit it. And this effectively uploads the data set to the backend. At this point, it's validating to make sure that that data set has the data that you want. So your next step is then to create the fine-tuning job with the SDK. To do that, it's a really simple method call. So you're doing fine-tuning.jobs.create. You're going to pass in the file ID from that upload in the previous step. Tell it the foundation model that you want to fine-tune using this data, and let it run. And the output of this is going to be a file job ID that you can then use to track the progress of your job. So if you keep going, you can check the status of your job. And there are many things you can do with that particular identifier. You can look at the events at a very low granularity, or you can just look at the overall status of the job itself. So what I've set this notebook up to do is for you to first look at it and say, what is the status of the job? And it tells you that the job is running. In other words, it's now in the process of validating your data and starting the fine-tuning job. But if you want to look at the finer granularity of what's happening, you can go ahead and you can actually track the events. And when you do that, you pretty much can sit on this particular cell and just refresh it. And you will see that it's going to go through that list of samples and train it. And if you keep refreshing, at some point, it's going to say the training job is done, tell you checkpoints are created, and now you have a new fine-tuned model. This is going to take a few minutes, but remember, I only had 10 examples, so you're at least able to see a response in fairly short order. If you use some of the more complex examples, and we'll talk about that later, it could take on the order of an hour or more for you to get these results. But for you to get the sense of it, this short example is enough. And you'll see that now it says there is a new fine-tuned model available in OpenAI, and the job has completed. you can now go into the OpenAI dashboard and look at the status. So over here, I have the OpenAI dashboard. And if I actually go in, there is a little panel here for fine-tuning. And if I kind of go into this, you will see that I actually have a record of all the fine-tuning jobs I ran. Many of them failed before they finally succeeded. These failures were actually because there were validation errors in the data. And you can see this is why having the right format matters. But the final version, they're complete. And now I have a model that is ready to try out. And if I look at this, this is the one that succeeded. It gives me the checkpoints. It also gives me, and I can go look into this, the messages and tells me the events that happened to get me to success. I can also go into the metrics and look at the metrics for evaluating these jobs, the kind of status of the job. But in the interest of time, let's go and see what happens next, right? So we've completed this. We've seen the status. We know the job is done. What do we do next? Now you can actually start using that endpoint to see whether that does the job you expected it to do after fine-tuning. And this is one of the steps of evaluation. You want to train it, try it out, see if the result meets your expectation. And if not, you may need to retune it, retrain it again. The interesting thing is once this model is deployed, that ID is exactly the same as any other model. So you can use the default code that you would use for chat completion, get back the ID of this model and use it in the exact same call to see what happens. And you'll see over here that when I now use the OpenAI chat completion request with this new model and ask it to tell me about another element, it actually returns it in the format that I had tuned it or trained it for. But wait, there's more. So now we can, if you run this in your own kind of environment, if you're on the notebook, you should be able to walk through this and play with it. Try it out. Change the prompt, change the parameters, change the data, see how things are modified. But wait, you can do more. You can actually go and see this model and how it compares against the foundation model right in the playground. And to do that, what you would basically do is go to the model. And if you go all the way to the bottom, it's going to let you open this up in a playground. And so when you open this up in a playground, it's actually, and I'm going to bring this screen over for just a second so we can look at it. This is what it looks like when I've got it opened up in a playground. You will see that now it actually has both these models. Is on the left side, you see the original model it was trained on. On the right side is the fine-tuned model. Let's go and try to copy the same thing that we were using for testing it. So we want to say, hey, I have a factual robot and I want it to say URL, a factual robot that answers questions with results and limericks. So if I put this in, note that when I'm using this particular format, both models are in sync. So when I put in a system prompt, they both have the exact same system prompt. And then I can do something like, tell me about, let's go with gold. And when I run this, it's going to show me how the two of them differ. It's going to tell me the latency, and it's going to tell me how many tokens it took. But the most interesting thing you'll see is that the responses are different. You'll see that this actually reflects the format that I wanted. It's kind of using even the, if you go look at the examples, you'll see that the tone of it is very similar to what I expected. It's also giving me the latency. This was faster at giving me the response, but it took more tokens. So the other thing you think about, now this was actually a very trivial example. So take that with a grain of salt. But this is how you would look at it and say, am I really fine-tuning it for the right reasons? Is it a tokenization cost? Is it a latency? And you would tune this and get your results out of it, right? So let's recap what we've learned so far. And we just looked through this notebook. You fine-tuned it. You were able to call it from the API. You were able to go see it in the playground and load it up and compare the notes. Now you have a fine-tuned model trained on your data. And you can go ahead and retune that model, give it new data. You can evaluate it and so on. So with that, we kind of walk through these steps. You create the job, track the events, retrieve the ID, ask the question, go ahead and monitor its status and compare it with your foundation model. So what's left? Well, remember that I said that fine-tuning requires non-trivial expertise to get the right results. So one of the things you need to know is understand the best practices and limitations of your approach and evaluate the trade-offs before you take a decision. So first, let's recap. Make sure you have a valid use case. In this particular tutorial, I showed you a very toy example. But your valid use case could be something that says, I need to actually have it do a new skill. Maybe it has to render an image. Maybe it has to do additional processing that I cannot do within the scope of a prompt engineering solution. So have a valid use case that requires fine-tuning. Then try the existing options first. Can retrieval augmented generation give you the quality you need? Is prompt engineering enough? Do you really need to pay the overheads of retraining, cleaning data, hosting it, deploying it, and so on? So evaluate your other options. Then estimate the costs and trade-offs. Understand not just the cost for retraining or fine-tuning your model, but the cost for maintenance, the cost for hosting, and so on. And last but not least, and this is super important, have a maintenance strategy. Once you've got your own model that you fine-tuned, you are now responsible for its upkeep. So if the foundation model evolves, if there are new capabilities, it's up to you to figure out how you're going to evolve your custom model endpoint. And with that, we come to the end of this segment. I hope you had a great time understanding what fine-tuning is. And let's summarize it with this illustrated guide. You learned what fine-tuning was. You learned why you should be fine-tuning and when it is appropriate to fine-tune your foundation model. Then, once you've decided that it's worth fine-tuning, we looked at how you would fine-tune it. And the steps really involve three things. First, find data, prepare it. JSON-L is the format we use. Upload it, and then train your foundation model on this data to get a fine-tuned model. Evaluate it for quality. And once you're ready, go ahead and deploy it and then use it exactly the way you would any other model. And with that, we come to the end of chapter 18 or lesson 18 of Generative AI for Beginners. We hope this was a super fast and easy introduction to fine-tuning. And we can't wait for you to go try out the notebooks and tell us what you learned on your own. Don't forget to check out the collection in the repository for resources, including the OpenAI cookbook and the Azure OpenAI tutorial, as well as a Hugging Face tutorial that will help you explore this topic in more depth with additional providers. Thank you, and let's keep learning.